Is everything working here? Hello everyone. Hello friends. I'm unshaved today. Sorry about that. Who is online? Let me check. Yeah, I took a nap because it was a long night yesterday. Oh, we have Henrik, Johnny, Anna. Hello Sharon. Random Hacks, Wodin, Lars, Fruchtzwerg, Aaron, so many, Red Madness, so many great people today. So what is the stream about, or how are your days today? Sparkles? Oh wait. Can you even see the wall? Which direction? Okay. I didn't connect the wall yet. I mean the drawing thingy. We need the drawing thingy, don't we? So, where is here? The NS panel. I still didn't build in the wall, but let's try checking if the wall booted today. Wet farts calling for duty? What? Hello M40K, Ray, Max. So many people, I didn't even announce it properly, the stream. Oh, I forgot to tweet that we're live. Let's not do it. Let's forget about it. Oh, the wall is working. Ha! Hi. Whip. Oh, no, it's not. Houston, we have a problem. What was that? Let me zoom out a little bit. It's not fully visible here. That's a H, an H, and this is an I. Or should we do O, hi, and exclamation mark? That looks like oh my. Oh hi. So, recap. Last Wednesday, it was an amazing stream. What did we build last Wednesday? That was the small... How is the microphone? It's a new microphone. I'm testing it right now. Let's say... Oh, I see there was... The clap was too much, wasn't it? Hello, bitluni brother. Okay, so last time we built... It wasn't like only one stream. We used two streams. We built this remote controlled tabletop vacuum, which is controlled by this remote that we also hacked together from Wii Nunchuck. Cool device, very simple, only I2C. And a battery, we can basically control everything with that. That was our... Should I turn it on? Yes, let me turn it on. The small... Here. It has a pink tail. And, let me turn on the remote. If I... I crushed the antenna already. Let's see how... I hate these antennas, they always break. Let's see if it's still working with a broken antenna. Let me turn that on. It lights up. Yeah, it's still... Antenna is still working. Oops. Yeah. So we can still control it. Vacuum is also working. Okay, cool. So this was last time. The best thing is the pink tail LED. It took us how long? 2 streams? 2 streams within 23 hours. We made this one with one sleep in between. But I want to take a break from that. Yeah, patent pending. We won't continue on that today because I need a break. Oh, I can't hear the text to speech. Did I break it? Uh-oh. I missed a call. No matter. Okay. Someone tested. Oh, wait, I can test it. The text to speech can be tested using Node-RED. Where is my flow? Node-RED flow. Okay. Wondering, I just powered it up. I have no clue if that works or not. Let me test that. Nope. Broken again. Text to speech. Oh, here we go.
I'm a bit late.
Oh, yes. Hello. So text to speech is working again.
Pepperoni, pizza and tortelloni.
Okay. That's not Italian. Let's put on the Italian voice.
Let's start the party.
Oh, I need to send it. Here.
Pizza me botluni.
It's a me botluni. Okay, it's a
Pizza botluni.
It's a botluni. I hope you can.
Let's go.
Here we go.
Eia it's a me a Mario. Pepperoni, pizza and tortelloni.
Okay, okay, it's done.
It's a me, Mario.
Let's waste another hour of our lives doing that. Okay. So, since the 1 day challenge is like really exhausting, it seems, I like to.
Let's interrupt him every time.
Okay, thank you for interrupting me every time. Since it's so exhausting, let's like do it every second week. So I picked a project today and you picked a project next week. Cześć bitluni, fajnie widzieć, że jesteś na streamie. Hello Marcin. Okay. Can you watch TV on your LED walls? Oh, yeah, that's a good thing.
Inidapu. One a plop, two a plop, and then a wipe, a wipe, then flush.
Ah, please. Okay, we did one project. It wasn't a 1 day challenge, I think. Was it? No. We used the Trinity board, so Brian's Trinity board, to live stream a screen capture on the panel. And basically, we could use the same interface to stream to this wall. And then we can basically play whatever we have on the screen. So we can run Netflix here and watch it on the screen. Or he's perfectly capable of doxing himself. Yeah, my information is out there. You're free to send me free.
You know a song that gets on your nerves.
Yeah. You are perfectly allowed to send me free fondue. Okay, I already started warming it up a little bit. I have even some bread. It's not the freshest bread, but it's good bread with some crust. Fondue cam on the LED wall. What? Here are some parts I hacked. Okay, that are only like remaining parts that are here visible on Fondue cam from the I started to work on VR project, and I have still this Gear VR.
It's a nota italiano bread.
Okay, not the Italiano bread. It's not a ciabatta. So I got this free Gear VR, and I hate Oculus. So
Wake up, Luigi. The only time plumbers sleep on the job is when we're working by the hour.
okay. So that came with free with my Samsung S7, but Samsung S7 already has like a cracked screen, so that's not good to use for VR. And the Pixel 3a perfectly fits into this thingy, except for that the glasses had some a micro USB port here, and I had to remove that. So I open it.
What do you mean you hate Oculus? Metaverse is so cool, totally not a file idea.
Not a file idea. I have no opinion on that. I didn't try it, but I didn't like the original Oculus. I had a pre-order on that, and I had it for one day and sold it immediately on eBay with profit, because I didn't like the resolution, and I didn't like that the system was closed. You weren't able to use like your desktop or virtual.
I don't like violence, Tom. I am a businessman. Blood is a big expense.
Blood is a bit what? Okay, I switched to English again. I get only half of the.
Oculus is owned by Facebook, so no thanks.
Yeah, that's the problem, and it's a closed system. So it was at least a closed system when I tried it, and I didn't like it. So the Vive, was it Vive? Yeah, it was like more accessible. You could at least have a virtual desktop there and use it for your own purpose. And as far as I know, you can still use the browser with the Oculus, this mobile thingy, and it's the cheapest, best one currently.
Is that a virtual fondue viewer, bitluni?
Virtual fondue? What? Is that a virtual fondue viewer? No, it's a real. Here.
Switch to Russian.
Switch to Russian.
Anyway, how are you doing, bitluni?
I'm doing fine. Yeah, okay, here. This is the next one should be Russian, but it's hard to understand then. Yeah, so I just removed the parts that connected with the micro USB port and basically lost the controls here and the charging capability. I just discovered that you could connect a charger here now after. Okay, let's switch to English again. Or here, that's the one I want. I just discovered this charging port when I was. Doesn't work. Okay, I just discovered the port when I was disassembling it like recently. So I used it all the time without the charging port. Okay, that doesn't work. What is? Oh yeah, I did a wrong language code. So that's the virtual thing. But what I wanted to start today is phased arrays. So let's before we continue. So last time here's the building phase of. Still doesn't work.
It's a bootloop.
It's a bitluni.
Okay, let's leave English. It's clear, loud and clear. So this was our last building session, and today I want to use the super cheapo ultrasonic sensors. I got like 10 of those from eBay or Ali. I have some, these are AliExpress here, some older ones. I have plenty here like that. And I have some from eBay now as well. They are all the same, 4-pin version.
Oh yeah, the ultrasonic ping sensors. Looney, where is Pinktail?
Pinktail, I showed it earlier. You were late. You need to rewind because Pinktail is okay. I will just power it up one last time. Pinktail for those who came late this time. Here, there is Pinktail. But we don't continue with that today. Sorry, we do phased array, like really boring, dull stuff, but cool physics. I hope that we get some results on that. So, how does this ultrasonic sensor work? We have like two transducers here that are working on very high frequency that is basically not audible to humans, but probably okay, for sure to bats and maybe to dogs as well. I don't know the frequency, the real frequency that is working. So there is a T and this is an R. So this is the receiving part, this is the transmitting part. There are also different types, these here, that only use one, which could be beneficial, but this one has a slight angle. So this is probably like potted, so it's water resistant.
Give me only one ping, Vasily.
One ping, Vasily.
You have to add a pink LED to the ultrasonic sensors.
Okay, yeah, I will use a pink LED with the ultrasonic sensors. So I can maybe, okay, we will change the list now. Oh, you know what? Let's make a new list. Let's use a different one because we could use that one. Oh, yeah, that's too big. Okay. So that was the fail indicator. That was a long time ago. Oh, we have even a cross. So failed stuff. We can change this list and ultrasonic phased array. Okay. US, it's not United States. Okay. Ultrasonic phased array. And oh yeah, pink LED is a must. Pink LED, I don't know on the ESP or whatever. That's like a mandatory part. So let's add it to mandatory will be the pink LED, and I need to open the other window for the unchecked box. Here we will.
Let's make Wall-E.
Wall-E? No, not today. Okay, we got the parts already, so we have the parts, maybe, almost. I will just leave it because we need a checkbox. That's an UTF character that I need to, okay, mandatory bonus. We don't text to speech, okay. Let me copy that empty box from that one here. We need to simplify this process somehow. Okay, so we have the empty boxes here. So next part will be to...
Frequency is 40 kilo HERC.
Oh, 40 kilohertz. Really? That's really low. So dogs will be probably annoyed by that. But the good news is we could test this to measure the, maybe we can even record it with a microphone. Even if we can't hear it, we could visualize it on.
Reminder to keep my headphones on then.
Okay. I doubt that this stream works only on 48 kilohertz, so there is no, the Nyquist frequency is like then 24 kilohertz. So sampling rate of 48,000 samples per second is the highest frequency that you can get.
Visualize on LED wall.
No, no, I will visualize it on the oscilloscope. So the highest frequency that you would be able to receive is probably 24 kilohertz, and this is already not audible to people but to dogs probably. I don't know if dogs can hear 40 kilohertz. Can you research that for me, please?
Hi all. What are we going to break today? What is the counter it, and which temperature has the fondue?
Oh,
The
that
LED wall is oscilloscope.
LED wall is oscilloscope.
Completely forgot about the sampling frequency.
Yeah. Hello, Brian.
People from 20 Hz to 1820 kilo.
Yeah. Me probably to 15 kilohertz because I'm already. Marion. Hello, Marion Makarevich. Free day to watch one of these. No one else is in the office. I can get some work done. Okay, cool. Hello, Marion.
Dogs. The hearing ability of a dog is dependent on breed and age, though the range of hearing is usually around 67 Hz to 45 kHz.
So, you have to be cautious when using these here. Do we have, is this the same frequency with these here? This is JSN SR04T second version. This is 04. This is T and second version. So it's quite similar. It's probably the same chip. So do we have a test dog? Oh, no. We have bats here. I have probably bats in the attic.
Challenge for you, bitluni next project done with everyone's room filled with nitrous oxide.
What?
Check datasheet. Hi, Brian.
Hi, Brian. Okay. I need to stir the fondue so it doesn't burn. I didn't have like proper breakfast today, so.
One day builds with our friend bitluni, the best on YouTube, or he will sue me. bitluni whacks and hacks these projects without resistance, so show some love and support his existence.
I'm surprised the text-to-speech ESP didn't crash on that because we are basically putting this whole MP3 into SRAM and decoding it in PSRAM, and that's a quite long sentence. Okay, so let's.
If you are using my chat library, you are reading the message in the wrong order. Fondue makes me hungry.
Really? In the wrong? Brian, why? Is there a bug? Do I need to update it? Okay, what I want to do at some point, I know I said the text-to-speech thingy, it was the last stream that we do on that, but I would like to, oh yeah, hair doesn't work yet. So what we need for hair, that's maybe a bonus today. Like a bonus is hair, start hair.
Will you go to phase array with many transducers?
Yes, I will. Start hair develop.
Woo, my blender render is done.
Devil. Okay. Sometimes newest messages. Yeah, I just used your code, Brian. I know there is no support. No, what I would like to change with the text-to-speech, I'm currently filtering this exclamation mark thing and fail. And this is completely done in the code of the ESP32. So every time I change something like super chats and so on, I need to do this on the ESP32. And I just thought, why doing it like that? I should basically just grab the messages with the ESP32 and send it to MQTT, not MQTT, to Node-RED, and basically do the logic there. So I can easily change it from the PC, and I could implement the text-to-speech or event that happens there. I could implement it easily with Node-RED and extend it for super chats and so on. Render Blender. Okay, so try. No, Node-RED.
Looney, do you watchdog program? I saw NASA update their Ingenuity helicopter via watchdog timer. Please explain how _L.
Oh, watchdog timer.
Then your noded gets the unfiltered input, load issue.
What? Explain hair. So hair is a typical gesture or typical sentence that when I'm confused, I say hair. So that's what Johnny requested, and he paid with many super chats already for this feature that was voted down on the last one-day challenge. So we didn't make it. I promised him we will make it at some point in the near future, might be today, at a later, like late night. But I want to start with the phased array, and because I need I need to work on a new release. I need to design a board tomorrow to.
Is the most common audio clip on the bitluni Discord bot.
Okay, yeah, we have on the Discord, we have some features. Lewis implemented them, aka sniff 122. Visit the domain. Some steering. Okay. Okay, try or visualize on Oscilloscope. Okay. Oh, Peter, thank you very much for the super chat. Ornay, Saxony style. Oh no! You mean that one? Or what? Oh no! Oh. But I'm not a good Saxony impersonator. What did I miss? Congratulations? Is it Peter's birthday or what? No. Okay, straight to the oscilloscope and hold against transmitters. What? You can desolder one of the transducers. Oh, SEK rules. Thank you, Johnny. So we have a new super chat. Connect it straight to the oscilloscope and hold against transmitters. Oh. So we want to use it as a receiver, but do we need to desolder it even? I think if we don't power it up, we can basically, since on the back this is like a through hole component, we can basically add some wires. Okay, we can do that. It's like, what? Alles gut? What? We'll do anything for SEKs. Oh man. Okay, so visualize so we can see the shape of the curve that we
I
get.
would do a super chat, but my bank account is a little dry right now. When I get some cash, I'll do one.
Oh, no worries, Sniff. You don't need to do that. You are young and you go to college and you need the money yourself for a new lens. You have 20 more ultrasonic sensor? Yeah. So there will be more projects on that, but we can start with the phased array. So visualize on the oscilloscope. Let's maybe do short explanation what I supposed to know or what I pretend to know. Explain, visualize. Then we get an impression. If we visualize it, we get an impression of the wave shape that we
Are we going to do beam steering?
Yes, we can. We can do anything we want. We are free. So, but let's set up the list first and we can continue with the explanations there. And maybe let's do a simple Johnny. Oh, this is for Sniff. Thank you, Sniff. Yes, Sniff deserves some attention. He coded the bot on the Discord.
Bitluni, I'm very interested of Russian S-400 air defense sensor Tears of Joy.
S-400 air defense sensor. Oh, we don't do military stuff here. This is a pacifist channel. No military allowed. I was asked for, so there was this art project going on in Hamburg. So they asked me if I want to participate in a, they want to get funding for a huge, why is this camera rotated like that? No, it's not. It's just, it's blocked here. Okay. So they want to build like a shipping container, put the shipping container on a building, and one side of the shipping container is a huge ping pong LED wall. It's thousands and thousands of, 10,000s of ping pong balls. And they try to get some funding for that, also on Kickstarter, I think, but it isn't launched yet. And they asked me if I want to participate, and there was one caveat. So they wanted to they wanted, of course, to document that and put this shipping container on top of the building using a huge helicopter. But this helicopter, they had only like the connections to one company, and that's weapons manufacturer. And I said, sorry, not with me. I don't want to have anything to do with war and arms and whatever. So I don't know how that works. I told them they should try, since this whole thing is in Hamburg, they should try to contact like an company that set up the offshore wind parks, because they have to mount the huge rotor blades for this 5 megawatts power plants there, the windmills. So probably there are different helicopters that would be able to millions to put this huge container on the building. I'm curious where this goes. Okay, so, but I'm already sidetracking here. We need to stir and we need a little bit more temperature. Okay, we can use JS to simulate. Sim in browser. We can simulate this whole array in browser.
I bet if the helicopter company thing WASNT doing that, you would do that. Electrons for peace.
Yeah, I will do it. I just said to them that I don't want. They might if they do it without any exposure. So the name isn't anywhere related to me, and I don't even want, because the company could probably deduct this as an expense for a good cause or whatever from the taxes. So I don't want even them to support this without any exposure. So because it's probably in Germany you could just deduct this as an expense, because this is like a gemeinnützig. I don't know. This is how is it in English? And okay, you get me. Okay, simulate in browser. We can use Canvas there, or in JavaScript. Charity, yeah. It's not charity. Is it charity? It's not charity. I think that's a different word. Where are the Germans here? Yeah, but let me check that. Non-profit, yeah, non-profit. That's the term. So since it's a non-profit company that's doing the art, they will probably deduct this as an expense, and they can basically deduct.
Looney, which model did you lead to make the ping pong display? Such as WS 2811 or WS 2812B, P.
None of these. I will probably take a different one. If I do it again, I would take a 12-volt version and one with the spare data channel. So if one pixel fails, only one, so the signal of one pixel is skipped. They have like one extra pin, I think 1 or 2 extra pins, where you basically route one of the data outputs. Yeah, 2 extra pins. So you have 2 data outputs and 2 data inputs. It's 2815. Okay, so basically you can route this to the next to the backup line. Yeah, to the pixel after that. So if you have a failed pixel, the pixel after that will see, okay, there is no signal at this data channel, or the signal is faulty. I take the other data channel and I skip one pixel, so that's the new data for me. So it's better, because then if one pixel fails, so you need at least 2 consecutive pixels to fail, that it stops working. Just bought 5 meters of 1111. What is 1111? Is this something new? Or do you mean 2811? I mean, they are still good. Okay, where's my Schwipschwap? Uh-oh, my drink. Oh yeah, good news, Schwipschwap, where I'm addicted to. The bottle is completely recycled, 100%. That's news. Oh, what's with the bitrate? It's a terrible, I see it's a terrible bitrate here. Or is it like, no. Oh no, I'm just, I need to pause this playback here. That's the wrong playback. Okay. Okay, enough of the sidetracking. Let's concentrate on the work. Simulation in the browser. Then we can do some experiments with that. We can concentrate like a direct ray, or this would be the best to shape the ray and do a scan, like maybe 90-degree scan or something. Tests, just experiments, and then the goal for today would be, that's a super simple thing. We should be finished with that in a few hours. And the goal for today is to do a precise scan. Precise scan. Yeah, let's skip that, so it's not cut off. Then we have this is bonus is if we still have time, and mandatory is pink LED. So at some point in time there needs to be a pink LED there. This is mandatory. So we got the parts. So I got a bunch of these. I will take 8 pieces. Why 8? Should we take different count? Maybe an odd count? We can test this if we need to take like 7 or 8 or 9. Because if we need one in the center, that's why we want this simulation for. Okay. What does this text chat say? Fruchtig status, what's this? Oh yeah, that's that one. Ali prices. It's all fake. Let's start with the fondue. So let's measure something. I will attach a wire to the receiver part. Oh
Wake
shit.
up.
Already got cheese on my shirt. Oh, this is salty today. Not sure if there's something wrong with that one.
How do you know if the chat is not just a YouTube simulation?
I don't know it, but
Bitluni made a mess already.
what did I do? Fondue time.
Salty cheese.
Salty? What? Okay, let's try again.
You made a mess already.
Okay, so
Who is the dreamer and who is the dream?
okay. let me check if I can, if to get the things explained. Let me check if we can do, okay.
Get master a copy.
Master of copy. Okay, here you go. Basically, you have the transducers, like here. Oh, let me enlarge that. Oh yeah, that's Wikipedia. Here you go. So, oops. Like that. So we have transducers here that are generating a wave. So we have like the sound, ultrasonic sound is just like any other wave, just a wave, a pulse in this case. But if we delay it a little bit, so this one sends the pulse first, this is the second, and so on. So what happens that we get this tilt here, the new angle of this wave front, and this is basically redirecting it. But this is not what I actually want to achieve. Let me check that. So you could use it as a direction. I want something like to what happens here. You can see that. If you overlap waves slightly, you get parts that are basically, if you have two sine waves and add them together, depending on the phase shift, you have some annihilation. So it basically is erasing itself at some points, and on other points it's getting stronger. So this will basically look like that somehow. This is a phased array. You can see these are the transducers. So where it's hot, you can see this is where the ray that's generated by the transducers is aiming.
Interference pattern.
Interference pattern, yeah, here we go. That's the one what I was looking for. Okay, so this is a great visualization of that. And what we need that for that, we need a wave. And if it's not a wave, then it will be harder to do this like annihilation here where
You'll get troughs and peaks.
troughs and peaks of power. Yeah, but I think this is what we can get, but I rather want that
Need
here.
a wave? Okay, then waves.
That's a different voice. Okay. Yeah, and I don't know if we can see what we produce at the end. We can maybe submerge it in distilled water or something, the whole thing, and I hope it doesn't short anything. Probably the transducers will break.
How on earth did that happen?
I don't know. I'm confused. Maybe we can see it on the water, and I don't know if you can send a constant pulse or anything. So we need to test that. So this was the short explanation. Oh, where's my building phase?
Submerge it in alcohol and put a lit lighter to it.
Yeah,
Sup, bitluni?
I thought about that. Hey, Stuart. if you missed that, Stuart, we are trying to build a phased array of ultra cheap ultrasonic sensors today. Where's my text that I wanted to add here? Building phase old, I think. Oh, yeah. Oop. Okay, explanation is more or less done. I hope you get it. You can basically, while I'm trying to achieve something here, you can try to maybe read some more on Wikipedia about that. Okay, so this is what okay, and I can check off the explanations for now. That should be enough. We have a good visualization. We can try to simulate it later. Five meters black PCB. Okay. So you are checking on AliExpress if the prices are scam or the discounts at least. Okay, so next on the list is get it on the OSCE. Oh, you know what? We might not need to desolder it. No, that's not the one. Because this one here, this transducer receiver thingy, has a connector. And that's basically a 2-wire connector. I suppose there is nothing inside there, it's just potted, because that's water resistant. So we can basically take that one and measure it. We just need to set off the pulse. So let me set up the camera. Oh, it's still set to 50 nanoseconds per division here. From my stupid experiments with the speed of light that we did earlier. Okay, where's the camera? I got a new lens, but the seller on eBay sent me the wrong one, the wrong version. The first version, I wanted the second version. It was a cool 20 millimeter.
I think you can trigger the transmitter directly, but probably you should not use the typical library. See carrot.
I won't use the library. It's basically a pin. I think I would write directly to that. Okay. Let's use the power supply. Oh, I need to fix the other one. One of the power supplies are broken. And
I got the camera now.
which one?
My camera.
Oh, okay. Okay, maybe we need a probe.
Your camera.
GH5, what? What are you talking about? Or G9? Oh, yeah, we could try to hack the G9. I saw there is a hack for the G9 to disable the recording limit of 30 minutes. Okay, we have two probes.
Our camera. Your camera is now mine. I stole it. RZ.
Okay. Here. Trusty jumper wires. I will only use the good ones for this experiment here. It's my favorite one.
Oh yes, we should do that if we have time.
Should be easy. It was like a 3 minutes video that I saw. Okay, which one is ground and which one is... Should it matter? It shouldn't matter. Can just... It's probably just a crystal there. Yeah, it's a piezo crystal.
Just a case of updating the firmware of the camera. I sent it.
What? Is it? I don't think that you need to update it. You just... I think there's a service menu as far as I scrolled through the input. Okay, let me do one time trigger. We can switch. Oh, yeah. You need to see it. So, anyone knows how the sensors are built? I think there is a piezo crystal inside, because it should be... Oh, no. The tilt.
On the Nikon cameras, you need to use hacked firmware.
Okay. Yeah, not the Nikon dude, am I? Okay, camera switch. Boop. Huh? Okay. Here we go. Yeah, you don't need my face, you need the camera here. Boop. So, do you see that? There was, oh yeah, did you see that? Let's trigger. Oh, this, yeah. Trigger, how do we do a one shot here? Single, yeah, that's that one. Here we go. Ha! But is it a good one? I think we are still, no, that's... Control is at its limit. Oh yeah, we need to set... acquire, and I think we need...
Go get some keys and jingle them in front of the sensor.
Oh, keys, yeah, that's true, that is possible, but then, I know what you're trying to do here. You want to replicate my keys for the lab. No way I would do that. I will take an Allen key or something and smack them against each other. Not my key fob or my keys. Sampling rate. No, I don't need that. I need to just... How many mega samples?
Who's Alan?
Who is... Yeah, I don't know why it's... I would call it hex. Let's do 100, no. That's a million. 100 million, 1 giga sample. Oh, enter. Mega points, okay. Microseconds, okay, this is microseconds. Huh? Okay, let's do 200 million. That's right. No, it's still at its limit.
Dump Alan and get with Philip.
Philip. Okay, so.
How many bitlunis does it take to operate a scope?
Okay, so this is the pulse that we get. So it's basically a crystal. Where is my horizontal? Oh, it's quite long, the signal. And why, okay, let's do display.
4.
Acquire normal and no, that's not the one. Horizontal time mode. Okay. Okay, here we go. I didn't see anything. That's okay, there is something, but it's so short. Let's do, okay, there we get something. Oh, yeah, let's run. Single. No, single doesn't work like that in this mode. Oh, my finger hurt already. Okay. Zoom. Woohoo!
Just whack the sensor off the desk.
It's not, maybe we need more. No. Okay, this is easier. You can see it, but I will.
Looney can use screwdriver for ding dong open mouth smile.
What? Okay, so this is what we receive with that one, but it doesn't really mean anything. We just need to generate one blip. Oh, the fondue is hot.
Did you know about the man who tattooed rabbits on his head? From a distance, they looked like hairs.
Oh, okay. No. Now it works, yeah.
Lol. Needs more cowbell.
Okay. It's more fondue. Hot. Okay. What kind of course we are using.
You can never have too much fondue.
Yeah. Let's use the one that crashed on our on us last time. So this thing here, ESP32. I tried to program it like with a. We had some problems last time, but.
We have magic smoke.
Where? What? Stop it.
Eating fondue is a diversionary tactic. You won't fool us.
Remind me that next time I will put a cooldown on every person for this text-to-speech to track the people and put a cooldown for this text-to-speech on individuals. Ha ha ha. Mean, isn't it?
bitluni here. Bitluni clearly doesn't know anything about electronics. Magic smoke in the chat.
Oh,
No, that's not funny.
John Macri,
Because
Macari.
of this, meow 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 grin.
Okay. Okay, this is obviously a too small breadboard.
We want more smoke.
You know what I found? No, this is a different one. This is a product that's still going on. Where do I get a breadboard? We used the last one last time. Oh, shall we disassemble this beauty piece of work? We already stole the LED from that. I'm still attached to it. We spent so much time assembling this thing. I will leave it. I take another breadboard.
Chant with me. Magic smoke. Magic smoke. Magic smoke.
Okay.
No disassemble.
No disassemble. Okay. So let me grab something else. Or I just buy a stack of breadboards. Obviously they won't ship today, but at least next time we have plenty of.
Looney, which BMS are you use 3s or 4S?
BMS? What do you mean? I use whatever I need. I don't know. Different ones. No disassembly. Okay. You know what? Let's not use a breadboard. I will just attach the wires directly to the microcontroller since we have some pins soldered. While the Arduino IDE is loading,
Let us mill a breadboard.
That's so great.
Cheese and breadboards, nice slightly smiling face.
Okay. So, we want to see this one.
Excellent decision. On the fly power on soldering. I want fondue.
Okay. Oh, this is the one. I think this is still like probably in a boot loop. Oh, it doesn't even show up. Uh-oh. Or is this only a charging cable? It might be only a charging cable. I'm not sure.
Peekaboo.
Let me test that. Here we go. Yeah. This one is boot looping for whatever reason. I try to reprogram it again. I think the dev module is still right. We'll overwrite it and then I will keep reset pressed because probably the spamming to serial is preventing it from resetting properly. And I will release the button on upload. Here you go. Okay, upload it. Now let's check output. No, still boot loop.
Stuart has the solution.
What's with Stuart? Stuart has the solution. Dead bug for the that, yeah, we did this once with this audio amp, the small one. This is crazy. I still kept it somewhere. I think it's up there because it's so beautiful. Okay, this one doesn't work. I don't know why. Something is fried on this thing.
Should debug a modern CPU. Is bootlooping bitluni's big brother?
Yeah. No good. This is no good. Oh, we have... No, this is the programmer. Okay. But we don't have a header on here. Okay, let's try that one. If this is also boot looping on us. Then I need to solder some pin headers to that. Yeah. Okay. I don't know what we did last time. Okay, this is programming. Okay, no boot loop. Great. Okay, this one is working. I will solder on some pins. Solder on some pins, so let's take... Ah!
Can't remember, are you getting senile? Rolling on the floor laughing.
You're getting... Yeah. I get some cheese congestions in my brain. I'm well nutritioned, but it's basically all full with cheese. Okay. Get some pins. These are too short. Is this like, okay, this is long. Let me take yellow for this one here. Moment of truth. Can we break the pins so it breaks at the right count? Or is it breaking one off as always? Oh, yeah, we made it. This one worked. Okay, that one worked as well. Cool. Great. Oops. That was, oops. Sorry.
Let's just snap the board in half too.
I accidentally turned off the microscope. It will, I hope it comes on again. Oh yeah, here we go.
Light. Try twisting the headers instead of snapping them.
Twisting. Oh yeah, that's a good tip. So to get the right distance between them, because if you solder them on, they usually get tilted like that. I'm using a helper.
404 microscope not found S7 re Gen 7 tilde NW1X6 DR.
What are you talking about? Okay. Up. That's probably not very sharp. Here you go. Okay, let's.
Woo fun. My internet is playing up. Change the LED to pink while you're at it.
Oh yeah, we could do that. Which one? Don't say all of them. Oh, that looks like a cold solder joint here.
ASMR soldering.
Yeah.
Fan. How do you expect a needle or pencil? Domain equal. GLSXV9. All of them. All of them.
Okay. It seems the question mark is badly encoded in this text-to-speech.
Just saw one. Now three. How many are there? Fan speed.
Fan spin? What? We have 1 and 2. There is one power LED, one for the charging and one for the power, I think, or built in.
Is it?
Really don't want to miss one.
Slightly smiling face. Maybe use the solder paste for better welding.
Okay.
Question mark, question mark, question mark, question mark.
Okay.
Question mark, 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 question.
Don't do this, please.
Question mark, question mark, question mark, question mark, question. I was a little late. What are we building today using ultrasound? Undo emoji is a thing. So only two. Change all 5 of them plus we plus building LSXV.
Oh, where are my LEDs though?
Sorry. Really sorry for that.
Okay. Where's my box with LEDs? Oh, we didn't use it last time, so it has to be somewhere here. It's not organized already.
Why we can't have nice things.
Okay. This is the only thing that you can imagine that is nice. Uh-oh.
Now. Photo pressed by Peter Grinning Cat Face.
Okay, this is pink.
Hello, Johnny.
Uh-oh. Okay, I got the pink LEDs. I should basically keep them on the table here. So since this is mandatory, we need to, and I hope we solder them on the right way around, because I don't know, there is no way of knowing. I can turn that off right now. Okay, paste for flux. Oh no, this is the stinky flux, not using that today. Here is some flux. Boop. And boop. You can see anything, can you? I put on some flux.
The T is the anode H backquote L.
Yeah, that helps. Okay, I should basically take it off and look beneath it to see which way around the other one was.
No flux given.
Okay, this microscope is too high for me.
Hey bitluni, I have some vintage 5mm pink LED.
Oh, really?
I'll send you some. They're 15 years old. Lazy. Get the multimeter out.
No, no way. Oh, we can see how they are organized here. So we can see the small dot.
Just tell him to flux off.
So since I doxed myself already, you know my address. We can use the...
What about a diode meter? No need to go multi.
Come on. A diode meter is just a power supply, I suppose. Come on. Here you go. So we have this point. Yeah, thank you, my light here. So
There is a mains hum on your audio output.
oh, really? No, that's not a mains hum. It's my hot air gun. Oops. We need that one here. Okay, we need some flux here to refollow it properly. Oh, this... I didn't want a touch thingy and they sent me.
Like an aquarium pump.
Yeah, it probably is inside. Okay, that looks good enough for me. Yeah. Okay, let's test if that works. We need to cool it down first. Or should we? No, we just go for it. Do the second one and done. Not wasting time here. Oh, we have still this thingy on. Oh,
Cheap air pump.
is this? Why is the second?
Came to the stream. What are you doing, Looney? What are you doing?
Read the to-do list. And you can always rewind.
Is it a fail if the fail voice is not used just for fails? Does that mean we need to continue to use the fail feature? Hi Adam.
Can you see anything even? Is it sharp? No, it's not sharp. This is sharp. I'm a little bit restricted here. Somehow this lamp, it makes a good...
Hello
Haters gonna hate. I don't mind. There are probably people that are too serious. And we were fooling around in the beginning.
They better make sure to click it twice.
Yeah.
What's the thingy to the left of the oscillator? It also looked like a LED.
What? We did one next to the oscillator. Or
The person who told me to say this just threw out 30 new PCBs because he forgot to measure.
okay. We will just try it and then. Okay, so there is no
Use thumbs down as long as YouTube provides it.
YouTube. That's a very British. Oh, here we go. There is another one. Okay, you were right. Almost missed that. We will have only pink LEDs, so there is no way to know.
That's the one. The 0 ohm resistor isn't soldered on both sides.
Where? What? Let me check that. Where is a 0 ohms resistor? No, it's an optical illusion. Everything is all right there.
Now I understand why everybody uses the word fail. Before I thought that everybody thinks that your device is a failing grain.
Yeah, they are working too well. Especially that one, but that needed like a few.
We need pink, magenta, and fuchsia LEDs.
Oh, I think that one is a little bit more on the
Life is an optical illusion. Illusion.
Okay.
Optical illusion from fail lighting.
The pink LEDs that we got, they are more like more on the magenta side, so okay, I think this is the right way around.
Woof woof master.
I'm
Humming has some kind of rhythm to it. Maybe it is the heater pulsing. More pink LEDs, please.
okay, that's the third one. That's enough for today. No more pink LEDs.
While you're there, do you have an 80 megahertz crystal?
Yes, probably. Why?
Bark, bark, bark. The humming is putting me to sleep, ZZ.
Okay. Oh, this is rapid cool technology. I will use that as well now.
Master needs a hand.
Okay, I think this is cool enough. Let's let's check the pinkness of this pink. You won't be able to see it, will you? Okay, we don't need microscope. We need phase. No, this is GH5. This here. Okay, so let's try. Okay. First of all, we need.
If bitluni was a furry, what would his fursona be?
I need to move the camera over a little bit like that. Okay. So, pink time. Let's see. Okay, we see some pink here. Okay, this is the charging. Charging ping is slightly blinking. The other ping, I think we did a good thing here. I think that works. The other one is the built-in LED 21. I don't know which pin is used for that. But I think I used the correct rotation on all of them.
Result acpeated.
Oh yeah, task done here.
Wouldn't master be a black and cream Alsatian? That's the wrong shade of punk.
Punk.
It's wonderful.
It's
You need some Weller WXMT soldering tweezers. Result accepted.
yeah, send me some. I don't have a like some kind of post box or something that you can send stuff. Basically, but most of you probably know my address already. So what's so good about the other tweezers? Are they like super fine or super precise?
You could try a pack station if there is one near you.
Oh, yeah, we got one close to Aldi.
German Shepherd.
Yeah, that's a good idea with Packstation. I hope I get notified then.
Special anti-static tweezers.
I think
Is that already recycled cola?
yes. I think in my whole career, let's call it career, I never killed anything with static.
Looney Take next challenge, make maximum PowerPoint tracker and monitoring by especially 8266. Use the JS. Same. Nearest pack station is at the nearest Aldi.
Yeah. Really good cheese today.
The Weller tweezers are £300 without the control station. Chinese have anti-static tweezers made from bamboo.
Chopsticks. You mean chopsticks? Very precise chopsticks. That fish, that's solar panel related. PowerPoint tracker. What is a PowerPoint tracker? I don't even know what that's supposed to mean. Like, are you tracking
Looney
PowerPoint
tickles my
presentations? Looney what? Looney tickles my, yeah. With my charged tweezers. Okay, we did that. Now, we just output here.
I can make cheese.
Okay. Let me share the code. Desktop, face, this one here. So,
Master likes to rub my touch screen.
where's the ultrasound array? Still working on that. Don't distract me all the time. I will silence it a little bit. I don't know if it works still. Okay, so what we need a huge array where we record the response. So response is character boolean. Let's use character here, and then let's make it really stupid. Oh, okay. Let's make it 1024 samples, and then unsigned characters, so we can read maybe 8 sensors at once. I have killed a plethora of old 7.4 series ICs, but nothing new. I think they got their act together with protection on newer stuff. Yeah. I think I may have killed ESP32 because factory tests say GPIO 26 is high. Stopper then. Oh, maybe we killed the other one that is in the boot loop, but I think it's just a faulty one. Or oh, are we erasing the flash? We might just have, oh, it's probably something with the spiffs or with spiffs or with like EEPROM, where it stores the Wi-Fi settings. It might be recoverable. I just try something. I I will try to erase the complete spiffs on the other one that's in the boot loop. Where is it? I just lost it.
The bootloader.
Bootloader? Yeah, do you think the bootloader is broken? I don't think so. Where is it? It's gone. It escaped. Huh? There was the huh. Oh, here.
My Wi-Fi keeps looking at me.
Yeah. Okay, so what options do we have here? Burn bootloader. No. Do we want to burn a bootloader there?
Could
No.
just be bad code causing the boot loop.
No, we uploaded an empty code. So it's not the code anymore. I think if we change spiffs, what's the Rainmaker? No. PS RAM. What's a Rainmaker? Does anyone know what Rainmaker is?
You would need to download the bootloader and flash it using ESCTool.
Ah, really?
You
I
have plugged the fuses.
I have
What Rotter says, format hard disk.
Format C. SDK versions, yeah. Flash erase. Yeah, that's what I think as well. But where is it? Where is it?
Room RF, no preserve root.
let's do this, and then what? No preserve. I will just change the layout so it will erase, but I think that, oh no, will it erase the if we change the scheme, will it erase the spiffs, minimal? Let's do that. No preserve root. Yeah, you evil person. Okay, I need a new directory and my videos folder, which is really not meant for that. But we are phase array codes, and then this is camel case, whatever case, phased array. Okay, now we can upload it. ESP erase config. Oh, you mean at the beginning? Like that? Yeah, it doesn't work like that. Okay.
What is best, a fruit loop or a boot loop?
Yeah, we need to include something for that. Do you know what we need to?
stool.py arrays_flash.
Oh yeah, we can do that. Basically ESP.
Looney, read Bart's question, please.
Whoa, was motivational. Let me check. Red parts. All the four or 5 key devices on Amazon are all USB and need Windows to program them. Okay, can an ESP32 be used to look like a keyboard to a computer? Add far 5 keys, program, play. I think yes. The question is if you can make it like a HID human interface device or as Bluetooth human interface device. And I think ESP, well, let's check Bluetooth. There might be even like not Bluetooth serial. There might be even simple BLE device. Platform I/O. I think people are using it as a Bluetooth keyboard, isn't it? Yes, yes, I can post an Amazon link.
At bitluni's trash, sure. Wouldn't you have to use 5-volt circuits if connected by USB?
Wouldn't have. Sure, wouldn't you have to use 5-volt circuits? Why, what? What are we talking about right now, Peter? I'm completely confused what's going on right now. Okay. Yeah, the data signals are 3.3 volts. Okay, here you go. This is like human interface device. This is the keyword. HID is the keyword, Bluetooth HID on ESP32. This is what you need to look for. And okay, if HGE wants to connect to the ESP by USB to SPC to emulate a keyboard, shouldn't it return? Why should it return with 5 volts? I don't get it. Yeah, also that. But the S2 and S3, ESP32 S2 and S3, they have OTG built in, and they are also only 3.3 volts. The power supply is 5 volts, but we have always an LDO that converts that to 3.3 volts that powers the ESP32, and the ESP32 can communicate. Okay, we are using a serial IC anyways in between the regular ESP32, but the S2 and S3 have built-in OTG, which also basically is directly connected to the data lines. So they are always running on 3.3 volts. There is no problems there. And I would even connect them directly to 5 volts if it's for me. But I am like, okay, .h. So what was the header? Is it like that? Or ESP32? Or what's the header? What's the header file that we need to include for the tools? No, that doesn't work. Erase config. Oh, you want to type in passwords? That's like a key fob. You just plug it in and it will no. Or you press a button and then it will transmit the password.
Just ESP tool. PYArrays_flash.
That's an interesting project. Just using a button that connects as a human interface device. So the ESP connects a key fob that connects as an human interface device, and you have maybe a fingerprint scanner or something that transmits the password. Okay, let's check. No, this didn't help. How do I erase? Okay, I need. Dudes, I use the Pi erase flash ESP tool. Yes, I will. Okay, I'm distracted. Okay, you guys do the support and I try to find the ESP tool somewhere on my hard drive. Where's my ESP tool? If I need that even.
Python/m especially tool. After you erase flash, you will need to reflash the bootloader.
Okay. What?
You can do it.
Thank you. can't find this tool. Where is it? I'm too cheap to...
You can do it when you V&Q it.
We are wasting time with this old bugged thing. You know what? I will continue coding. No, shit. Now I got cheese on my pants as well. I will continue with the working one while this PC is still searching for these P-flasher.
We are fan of Looney.
Thank-
Cheesy pants.
Okay. Thank you, Jordi. Okay. Oh, here you go. Bootloader build. What is P2 pi? Oh no. I lost it again. Oh, I have the IDF. Okay. Wasting time here. Okay, so
I can DM you a copy of the bootloader over Discord if you'd like. I'm pretty sure I still have it.
thank you.
I use Arrays FLAS all the time. Never need to reflash the bootloader.
Okay. We don't need to do this right now. I can recover this part anytime. We're just wasting time. We need to manage our time better. Okay, so let's say we start with pin 2, pin mode, or let's say, okay. How do we do it? Okay, let's start with pin 2. Two and 4. Two and 4 by default is input. Let's mark it for input. Input is input. And then we can basically digital write, and then let's use 2 high.
Input, an integer input.
Yes. Delay. Okay, if we have 40 kilohertz, it was 40 kilohertz, wasn't it? So we want like one wave. One wave is how many microseconds? So we do like 1 second divided by 40,000. Wait, we want a complete, no, 40,000, but we want twice as many, no, that's right. Oh, no, times, what, okay, we have 1 million microseconds, 25 microseconds.
You are trying to access information from secondary school science that I have mostly forgotten now.
Yeah, that's the same for me.
Do you want to just ping the transducer?
Yes, I do. I want to do that. And I only want to send one complete wave. And since we have 40 kilohertz transducers, that will be 25 microseconds. So we ping it for 25 microseconds. And then for that's everything hard-coded for now. Very simple. Oops. Very simple. We'll basically read digital reads the other one. Reads 4, this is the receiving pin, and basically store it in response.
Do the transducers need a wave input or just one pulse and then they will resonate?
1 pulse, I think it is. We will see. We will see what happens. I used those before, so it should work somehow.
Just a pulse.
Yeah, just a pulse, okay. Delay microseconds, and then 1. That's basically it. So yeah, but we can basically store the delay. The processor is fast enough.
You give it a pulse, you get a pulse back, you use the time between the send and receive to
I know.
calculate the distance.
Yeah, but what I wanted to do is to record first and then calculate the, but we don't need like this high sampling rate. It's only like, oh, this is 1 megahertz. So we have only like 40 cycles to do that. And I don't know if we have enough time to calculate everything. But we can basically delay microseconds and do something like that. If then oops. Let's do like that. Response equals I break. This break because we have only 1. And this will be now unsigned int. And we have 8 channels, possibly, maybe 10 channels in future. And this is the pulse. Then we need we don't need anything here. We just wait for 1 microsecond and then check if it's getting high. And that's all. And then we do the calculations. We need serial begin 1.
If you want to record the echo, you need to mute the initial excitation.
Yeah, that's what we do here, low.
Getting high on what? Flux fumes?
Yeah. So, serial print line, and basically response 0, and we will get a microsecond, more or less. It's a little bit more than a microsecond because we have the loop around that and so on. So this is not very precise. We could use nanos or no, micros to get it from the program counter, not program counter, the cycle counter of the processor. But this is something that we can check soon.
You need to mute pin 4 during the excitation.
Look.
Accuracy. PFFFF, we don't need accuracy.
What? Mute? What? Everything is all right. We're not listening while the initial thing is doing here. Then we have a microsecond delay there. Let's try. We just need to try.
Your input pin is pin 4.
I know. This is here. Digital read. Dudes, look at the code. We don't need to do anything with the digital read. The input. What's wrong? Oh yeah. We have a separate pin for input and output. So that input stays always input. We don't need to do anything there. And the output is set to low and then high. High and then low. And then it's muted. Then we have 1 microsecond for each. The uploader of this thing is like a really terrible. Would not recommend this kit here, but I think it's a quite old one.
I can't read the code on 480p.
Yeah, sorry, that's not my problem. I'm streaming in HD. Fuck, it won't upload. Yeah. Okay. This is basically...
We are both doing some coding at the same time, coding buddies.
Yay!
Sorry, I got distracted looking at Jeff Gerling. Undo uploading.
Okay. We have some action going on here. Now we just need the connections, the 4 connections. You just have to trust me that I'm doing the right thing here. No. So we need VCC. Oh, I hope I have the right ones. They should work with 3.3 volts. This is ground, echo trigger, and shall I show what I'm doing here? Maybe it's important for those who want to build it as well. So, what we got here is the module. Ground, VCC. I will try VCC with 3.3 volts, otherwise we would need to do a voltage divider on the echo. The trigger should work also on 3.3 volts, but Basically, we connect this to 3.3 volts, this to ground, and trigger is the pin 2. So this is the pulse that we activate. And
I think I've had them work with 3.3V.
yeah, I specifically bought the ones that said 3.3 volts to 5 volts, but as compared to my thingies, they look all the same. So basically, someone tested it and it's working reliably. These things, the design is so old. It was around with the Atmel microcontrollers. So they basically said it's 5 volts, but...
Hi, Simple Electronics.
Hello, Simple. Here we go. This is ground, this is VCC. Oh, even the colors match more or less. Okay, and I will basically connect it to the microcontroller, or okay, let's do it together. Okay, so our VCC will be, okay, ground first, VCC, then
The design is so old, the engineer was a T-Rex.
yeah, okay. 2 is the trigger and 4 was the echo.
Magic smoke time.
Yes, magic smoke time, but not on camera. We just microscope off, or should I just switch to the face? Woo! So I will plug it in and then we see magic smoke or no magic smoke.
Magic sound.
Oh, something's happening. I can hear the loop. It's like 10 hertz loop.
Hiding magic smoke is a crime stoppers.
I need a longer 3.3 volts cable, micro USB cable, I think. No, this is, where's my long one, ultra long one? Okay, I need to take that one then. But let's test the output. Let's test the output. No good. Output no good. Okay, maybe we need... Oh wait, this one here. So, oh!
Hey.
Okay. Let's change the code. We might want to wait a few microseconds. Let's wait 5 microseconds so it isn't triggered right away.
TOF.
And let's do...
Exactly.
We need also to initialize it with like a very long 25, so we know it wasn't triggered here and wasn't set, and this is what we write now. Oh. Oh. okay, the range is like 1 centimeter or something. Okay, so we need to wait like a million microseconds. 1 second, that's 300 meters. 1 second is about 300 meters. We don't need 300 meters. So what's the speed of sound? It's 300 meters per second or what?
You are already listening to your produced wave.
Yeah, we will do it. We will do it. Wait. What's the speed of sound? ...330 meters per second. So we need just 2 meters or something. So 2 meters, 2 divided by 330, we get, wait, what? Okay, 2 divided by 330, this is 5 milliseconds, 6 milliseconds. So this will be like, so let's do like 10 milliseconds. So we need 10,000 micros is 10 milliseconds. That will be plenty enough to calculate here microseconds. Maybe even delay a little bit more, so we get some margin on that. Response.
If you sent out 2 pulses, could you use Doppler shift on the return to calculate velocity?
Probably, but I'm not sure if this module supports that. OTG?
According to the Hitchhiker's Guide to the Galaxy, the answer is 42. How precise has this to be? You need to change it in the loop.
Oh yeah, sorry. Wrong spot here.
You can just wait a certain amount of time or simply configure pin 4 in input after you sent out the wave.
Yeah, trigger. We could trigger. Can we do like an interrupt? But I don't trust interrupts here. I want to do it real time. Oh man.
What? Triggers brew back quote L. Let's interrupt bitluni with a fail.
Yeah.
Then use RTOS.
Yeah, that works well. Something's off here. Huh?
RTOS, what about TMNT? An RTOS will just get in the way of the timing.
Yeah. Okay. Let me check if that one receives. Maybe the pulse is too short. I should check my old code of the scanner that I made. Or so 1000.
Is the amplitude high enough to get a clear response from large distance? What does the chip specify as the minimum pulse length? If you're not using the bare bones transducer, then you will need to read the chip's data sheet.
Yeah. I will check it. I will check it soon. I like to experiment with stuff and try it myself. That's like a very random number there. Okay, I see something on the scope. Let me show that.
Hi.
Hello.
bitluni likes to fail.
Yeah, I like to fail. So and let's check on the. Let me grab this receiver part here. It's not receiving much though. Oh, yeah. This is the time where I check on the module.
The Oscilloscope.
So the name is HC SR or 404. Oh, it's all German now. Oh, maybe take the data sheet here. Spark Fun. We can trust that one here. Oh, you can see. Oops. 10 microseconds. TTL. Oh yeah, that's terrible. Look at this, the resolution that we are working at. 340 meters per second. We got almost everything right. I think this is still muting. It's muting. 8 cycle sonic burst. So we get it no matter what. And we need to have 10 microseconds on the output. Let's try that again. And then I will just grab my old code and use that. Why reinventing the wheel if I reinvented it already? Here you go. ESP2 and ESP8266 was the last one made on.
Why reinvent the wheel? Because it's fun.
Yeah, I know. No. Oh, I used the other one. Yeah, that's not comparable. I used other fruit library. Okay, let's try it ourselves. That's not comparable. It is a different sensor. Where's our output? Wait, not scanner. Did it upload? Yeah. I think it's uploaded. Okay, there is a slight delay. Let's check again. Working voltage 5 volts, but we can use it with TTL. Okay, so let's connect it to 5 volts and let's hope it doesn't fry.
Measure the length of the echo pulse.
Let's apply it with 5 volts and fry the input pin. Here you go.
TTL, Nikon's through the lens. Sorry, I'm too much of a photography nerd.
I checked the pulse. Do I even get anything? Trigger. Oh, I disconnected. I disconnected the thing already.
Pulse in, 4, high.
Oh, pulse length, but 4 is the receiver.
Old school ECL.
Okay, the receiver doesn't do anything. Input pin, yeah, that's 2. It's pulse a function here. So, but we have, this is the pulse. Pulse length 4 high. Oh, is this a function? We can try. Yeah, but it's not high. It's like, oh wait. Where is it? Sorry. Oh, this is in proportion. Okay, so this is the one. Okay, great. So let's do it. Let's try it. We don't need to do this manually, but we should do it later because we need a phased array. So we need to control every pin at once. Thanks, Antonio. Ah, come on. Oh. No. Ah, here we go. This is close. What is this value? Ah, that looks proportional to the distance that I'm using. Or it's too far or too close.
Great. Now you need to scale.
Okay. Now we do it ourselves. So what we measure now good night, Chris. So what we measure now is what I did wrong before is we need to wait for while not, and there is a timeout. We don't implement the timeout, but then we measure them, not even the microseconds. We take the time. So let's say and this is nanos, no, micros. time ticks. What's the ESP has specific clock cycles. We'll check the distance later, the proper distance. I want to count the cycles. I know it loops around. No, I don't. Millis is too coarse. There is a specific register for the clock cycles. Here. Cycle count. And now, while digital read 4 and then unsigned long dt equals this minus time t. Let's call it t. Oops. Because time seems to be a keyword already. Let's use a dt, and that's all for now. Okay, this is the scheme. Oh, xtal get count. Is it the same? Fruchtswerk? Because we need a great resolution here. The best, oh, deadlock. That doesn't work at all, dudes. What is this? This is like completely random.
Especially get cycle count can overflow.
Yeah, but if you subtract it and cast it to unsigned, it will be again good again. If the cycle count is like, I think the register is 32 bits. So it will overflow every few seconds. But if overflows and you subtract and cast to unsigned, the result will be correct. Pulse length already does, but there aren't two pulses after the trigger. That won't work. What's two pulses? What do you mean with two pulses? Where? Oh yeah, here, that one. Yeah, sorry. I forgot to erase that. Yeah, someone used the link, the Discord link. Ah. I just wanted to replicate it. We wanted to measure the secondary reflections here. Oh yeah, baby. That's what I'm talking about now. What is this 39? That's like a, too close, can't read. Now it's stuck. Yeah, the 39 is probably the cycle count.
How can that fondue last so long?
I don't know. I need to take care of that, but we need to code faster because of the phased array. Oh, I need a timeout. It gets stuck.
You could measure the depth of the fondue with your ultrasonic rangefinder grin lol.
Yeah. Oh. How do we measure it? Why? What's our timeout? Millis? But that's like okay, let's do it like that. Timeout equals millis plus 1000. Okay, so we just wait 1 second here. No, millis, what I say? Millis plus 1000. So we wait 1 second and then we just compare it. Millis are greater than timeout. And we hope that we don't get some overflows here, but I think that will work. And same thing here. It won't be like the resolution will be reduced because...
Could you show us the device?
No. No. No way. Oh wait, we need timeout. Timeout. What do you need to know?
Millis, less than timeout the device. You are not nice. And millis, less than timeout.
Oh, yeah, less. While it's not until, okay? You're right. What do you want to see? The cable is so short, I can't...
And the end.
What?
And not OR.
Oh yeah, not or, yeah. No! Now we have two concurrent compilers. Okay.
We have no clue about the device.
It's broken now.
We just arrived.
Oh, wow. I don't know what's happening here. Maybe it's a broken wire or something.
Fail.
Yeah, that's what I would also say. Let me try that. Okay, 3.3 volts.
If you don't know what's happening, how am I supposed to know?
Okay.
Have you tried turning it off and on again?
Yes.
Point it to an even and hard surface. Could it be getting stuck on the other for loop?
No, it's not stuck. It's always
285.
yeah, that's the minimal cycle count. It counts the cycles between between the two readings
Is
here.
there any maximum sample rate for this sensor?
No, the sample rate doesn't. It's reading like a fixed signal here. So this is like from the data sheet, 10 microseconds. And then it will be triggered. And the length of the signal is proportional.
Hello everyone.
Hello.
From DIY in the ghetto LOL.
So trigger 10 microseconds TTL. Then we get the burst from module. Then this is the TTL layer in proportion. As easy as that. Okay.
Is there no working lib?
Yeah, let's try a library just to see, just to compare. I mean, we get something, but it doesn't look like it's reliable right now. That's what you get if you buy such cheap ass modules. Okay, this is everything below 300. I will skip.
Pull up.
Is there a pull-up required? Did you read that? Sorry. If DT is higher than 300, because we don't get anything meaningful below that. So we will skip the shitty values.
Is this No Shade November?
No, I forgot. it looks like sometimes we get some meaningful values and then sometimes we don't. But basically, there is no need to wait like a second.
Try the serial plotter to get a nice graph.
Oh yeah, that's true.
Do you really like fondue or do you just do it for the videos?
I do it just for the videos, you know. Why would I torture myself? I eat the whole bread now.
58 equals 1 centimeter. You are doing it wrong, trademark.
Yeah? How is it done then? Johnny. Oh. Comport busy. Oh, come on. Annoying piece of...
Wrong channel, Johnny. I hate coding. 2 steps forward and 3 steps back.
Yeah, but then at least you advance in some direction. You just need to turn around and do the same what you did so far, and you will go in the direction you wanted. Come on. Yeah. I will try the same with the other sensor to see. Yeah, this is the serial plotterer. Okay, I need to filter anything only when bitluni is what I'm doing. Brian, is your unicorn speaking already? It's always a slope down, it seems. Slope down, bam. Slope down, bam.
Looks not right.
Oh, what was that? 2 million overflow.
This will not work, H back quote L. They said only when you do it is all wrong and backwards LOL.
Okay, let me try using the other sensor.
Plot it with the pulse in.
Oh, wait.
Is it working with an Arduino Uno? Wall 2.
I think that might got hot right now. Is this the trigger and the VCC? Maybe we flipped the trigger and the VCC. Oh no, 5 volts. Trigger. Wait. Trigger. Oh. Okay. Let me try something.
Get a VL53L0X instead.
No.
You need to turn off interrupts.
No. I might have spotted a small boo-boo that we made.
Does not look like filtering would be enough.
Look at this. Bam! Oh, sorry. Sorry for those who used headphones. Something got hot here. Okay, this is trigger. Trigger is to... I might have switched trigger and not trigger. Trigger.
Magic smoke. Please reset the plot.
Okay. Okay, this is the other one. This is this one here. This works now.
Do you use pulsing?
No, this is our code and this is working. This is like proper, okay, close distance doesn't work. Now it works. So we have like 10 centimeters distance. This is, I can scan my complete room.
Distance to the magic smoke equals 0 centimeters long.
This is scanning my room. That might or might not look square now. Okay, this is working. Let me sense it on the scope. I might have had used the wrong pins for trigger and
I
signal.
lost the plot hours ago.
Okay, yeah. That won't work here. The receiver.
We know it's a green screen.
Green screen. Ah! What? Okay, anything, I aim it back there, anything above 8 million is like broken signal. 8 million, no good. Okay, this is the code. Now we have to try it with the other sensor because, oh, I'm drying out the cheese. Okay, cheese is done for today. Now we can start working. We got the code here.
Where's the fun if it worked first time?
Is this a check? Okay. Let's see the plot. How do I clear the plot? Is there a way to clear the plot? No, it's not. Ah,
bitluni lab tour part 1 distance.
yeah. We can measure the distance now. So what a meter is in clock cycles here. Let me get this. This is 2 meters. I can't aim at one of my ping pong LED walls because they have stealth technology. Okay. Fuck. Yeah, something like that. Or no, wait, I can basically flip it. Okay, so I will aim it at the wall, and you guys check for the values that we get. What's the value? We can see, huh? Okay, let's switch to serial monitor. Ah! Okay, so let's measure 2 meters. This should be 2 meters. Ah, no, no reliable. 2 meters, let's say 5'9", 5'6", 6'9". Let's take 5'9", 6'1". Like that. These are 2,065,000. 265 meter. Oops, 650. Okay. Oh. CPM, clocks per meter.
What is the especially CPU clock?
I don't know.
Divided by 2.
Oh, come on. There's this.
Lol, it is in the settings.
Oh, yeah, it is. Yeah, divided by 2. You're right. We measure 2 meters. 6, 2, 5. Yeah.
Does it say especially for ESP?
The clock cycle and the actual clock that he's counting, or the oscillator, is like different. It could be 80 megahertz, it could be 40. So the main clock runs at 40. Or is it 80? Nobody knows. I don't know. You might find out. And tell me then. Okay. So yeah, look good, look good. The good, them good. Here, 20 centimeters, anything shorter than that breaks apart. So we can reliably measure maybe to, what is that? 3 meters. 3 meters 70, that's cool, that's working. Okay, now let's switch the module. Switch the module. And see what happens here. Nothing. Is it broken? Did we break it? No. No worky. Let me take that one here. Eh? There is nothing connected. It measures measures floating pins. Okay. Let me check if we need 5 volts here. Yeah, input needs to be 5 volts. Okay, VCC needs to be 5 volts, but the TTL signal works. Yoo-hoo! Okay. That was difficult, dudes. Oh, sorry. Oh, okay. We can only go as low as like 30 centimeters. No, 15, 10, you never know. No, for sure. Okay. So can we make a phase array? A phase array. We need precise distance holders here for that. I need to know, right now I need to know what we are using as pulses for. It's my other power bank. Since we might need to control it properly, what happens if we send like similar to if there's a difference between our individual modules, if we get different responses or something like that. I hope they're like, I don't know what. Do you think we need to use like the transducers ourselves and generate a signal, a driver or something. I don't know what we need there, current-wise and so on.
Generate a standing wave between two transmitters facing each other.
Antonio, what for?
Scope the transducer.
Yeah, I can basically just scope one transducer that I'm aiming at the wall and see the response, but I need to solder some wires on first. Let me get some test wires. Some probes. We need some testing here. So I will switch you to the microscope.
To measure that the wave is eliminating itself at certain spots.
Yeah, that's, I mean, oh yeah, we can use one to sense, but if we just try, so first thing what I would like to do, I just take one, like this one here, I will attach wires so we can probe it easier. Maybe even just a silver wire, but I don't want to short it. So that could be a potential issue here. Do we have a ground pin here or is it? Okay, so what I see, so this one is connected at the other side. That could be a ground plane. No, that's a crystal or what now? Where is this going? Should I desolder one to test it, to see what's happening? The circuit? So this is a driver. This is driven. And this one, is this divided? Oh, there's a capacitor, 1000 ohms. Is there something in between? No, it's just AC. It goes there and what not. What is this? Is this ground? Is this, I can see that properly. We could measure what's ground. Let's probe it with the multimeter. So which one is connected? Okay, this is ground as I suspected, and this is probably also ground. No? Hasn't. It's probably, whoops. Okay. So that one isn't. That's like something special here. But that one is ground. Okay. At least I know that, so I will not short the oscilloscope.
I have a link to the schematic.
Oh, cool. Who is this? Do you have rights? No. Antonio, I can give you admin rights for a minute, or so you can post the link. I don't know if we really need them because we don't want to reverse engineer that. If our phased array thing is working, if we need to reverse it and basically implement what they do there manually to be able to use it as a phased array. Okay.
Should be able to post the link and have an admin approve it.
Oh, yeah?
Just search on Google for HCR04 schematic.
Oh, yeah, okay. Come on, this is like stupid touch. I need to disable that and basically solder on a knob. Okay. It just turns off. I have no clue why. Or is it overheating? No. It's just a basic lamp. Why is it so annoying? The electromagnetic interferences are too high here.
Where is your enameled bodge wire?
Don't need one. Okay, here we go. Let's scope stuff here. This is the receiver. This is ground. I just say that's ground. And on the other side, we just need, I hope, we don't need to attach it. Okay, now we just need the power. And I don't have a cable that's long enough. So. They are all in use for microphones and so on. All the long ones. I have a power bank. One power bank was used for the mini robot. This is the second power bank. Okay, it can work. And we don't get a short to ground since we are using a power bank for that. What happened to the chat? No! Oh, sorry. That was an accident. Didn't want to disable you here. So, is there something happening here? Oh, there is like a short pulse. Oh, wait. We need horizontal.
Counter reset.
Which counter? Accident counter. Yeah, that's not an accident. Okay, that's microseconds.
Accident counter reset.
That's not an accident counter.
That WASNT an accident. I am an accident.
Megapoints per second, that's like really low.
Again, how many bitlunis does it take to operate an oscilloscope?
Many. Oh, come on. Why can't I just zoom out? I don't need like max. I need a better time zone here. Time, not time zone. Why is this so annoying? Default. Default. This is good. Okay. And then 80. Okay. So let's see what we have here.
Horizontal scale knob.
Oh wow, I don't see anything here on this one. How? Let me just auto everything here. Auto scale. Oh, here we go. That's like you're probably not even able to see anything here. Let me set the trigger. Ah! Oh, this is the in. How anyone can see here anything? Okay, here. Is this what we get?
Use the HCR04 trigger pin as trigger input to your scope.
Oh yeah.
Auto button winking face. Your channel 2 is clipping.
Yeah. I know. Let's use channel 4 as trigger. This is ground. And this is the trigger signal.
I smell magic smoke.
Yeah.
Professional daily scope user here.
Yeah, totally. No, 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 no. I'm shorting pins. Okay, here we go. Trigger, source.
I am so clipping that.
Yeah. Stop. Source. Where's the trigger? Huh? This is not. Source is 4. Trigger type edge.
It's the pink channel.
Yeah, but I don't see anything at the ping channel. Oh, wrong one. It's the echo channel. Pin 2, isn't it? No, this is 2. Oh, this is 4. It was the right one. Okay, let me reset everything.
Why are you making it hard for yourself? Just hook the probe on the ESP board.
There is less space than here. I have connected it on the other side. I don't know if you are able to see it. That's the trigger signal, the 4th probe. But I don't see anything there. Something's broken. What's broken here? Let me turn that off.
Reset your trigger position.
Okay, stop for a minute. Let me check the trigger position.
AC or DC coupling. I made that mistake a while ago.
It's
once.
DC. It's okay. Please
Click
shut.
on the trigger knob.
I turn you off for a minute, okay? Just let me do for a second. I don't see a signal right now. While there should be one. Okay, we are time outing maybe. No. Time is at 2 volts per division. Voltage. What's with this probe? Did I destroy it already by shorting it? They short it somehow. Let me check if I broke it. Let me check that. If we get an output still. Sorry, I can't hear you. Ha! You are powerless here. The trigger mode is normal. Edge, source, slope. What do you mean with normal? There is no normal. Okay, so this thing is working. Okay. Okay, good night, Anna. I will turn it on again. Now we need to see what's the matter with this one here. Really don't see the issue. So pin 2, I try to measure it here.
Be very, very quiet H backquote L.
Where is the trigger? Why don't I see anything here? What's the matter with this thing? Let me take that off.
Try single shot.
Won't trigger.
Set the trigger to normal mode. You're on auto. Key M. Up plus BF3. UDDG asterisk.
Trigger mode. Where is my auto? Where? Okay, I aim at the button that you want me to press and you say hot, cold, here?
I think you find it at the mode button.
Mode. Mode. Auto. Normal. Okay, normal. And now? What do I trigger there? Is this what I trigger?
Bingo.
Oh, that's 5 volts per division. That's what he said. Okay, I saw something similar before, but okay, let's do that. Now.
We got it.
Okay. Yeah, you got it. I wasn't really participating in this. Okay, so how does this here work? Well, what is that? What is? Oh, that's the burst. Look at that. That needs some AC coupling.
Bitluni is just our puppet. He does what we say for him to do.
Yes. Okay, so DC, AC coupling, DC coupling, whatever coupling. Yeah, that's AC. Interesting. Okay, so we get, this is 1 volt, 5, the first one is 5 volts. So we get a peak-to-peak voltage of like 5 volts, and it's, oh, that's sweet. I love it. Okay, so here is the trigger signal. Let me move that down. So I will, maybe I do it like that. This is our trigger. I don't need the cursors. Nobody needs the cursors. Five volts per division. This is our trigger. This is our signal. It's just a basic pulse. 5 volts. Sorry? Do you see what I see? We just need to pulse like, this is on the transducer, and it's basically 5 volts. What's on the... What? Curse the cursors. Let me check the second, with the second probe, what we get on the other pin. It's probably just AC or something. Oh, what's that? No. That's also 5 volts. Yeah, it's basically like flipping to have to double the voltage. So this is just AC. So we can use like an H bridge for that.
The echo is way off to the right.
Yeah, I know. We don't measure the echo right now. So this is like this differential thingy here. So the voltage difference between, like, the amplitude is 5 volts now, because we have the difference between, can you see it even? So I'm measuring this here are the 2 pins of the transducer that's transmitting it. So they are like flipping 5 volts back and forth. So we get an amplitude of 5 volts, and the total like difference between these pins is always like 10 volts. Is it? No, it's 5. Push-pull. Yeah, that's what I meant. Okay, cool. And the frequency, we can measure that. We can measure the frequency. Yeah, that's not like let's measure rather here. 40 kilohertz. Okay. It says 40 kilohertz. Wait, you can see it. It's behind the wait. Here. The measurement says it's 40 kilohertz. So it's basically, we can do this ourselves. We don't need the board for that. Now we need the response. So let's add the probe, which is, one pin is always to ground. That's what I figured out already. So we can measure what we get here with this one here. Okay. Okay, what do we get? Where's the response? Where's the response? Oh wow, it's very low. We need to amplify that. We need an op amp here. So let me check.
The board is already amplifying it.
Yeah, the board. But
The op-amp is on the board.
yeah, I know. What I want to know is how the receiver gets the signal. So if we would want to like not use the board, only the receivers to get our own implementation. Yeah, but this is like nonsense that I get here. Okay. So what's the response? This is the response. Why is this floating like that? Okay, so this is like an oscillation here. These are the echoes. That's my hand at 10 centimeters and moving away. So we have this peak close by, and then let me show that. So here is the sensor.
Measure after the RC filter.
Okay, I can do that, but here. So I can already see it's moving close, and okay, let's try the RC filter. I think this was the RC filter. Nope. No. I don't know where this is. But all I needed to know is how the signal looks like. We could work with that even without the whole board that we get there. The problem is to distinguish or get this amplitude.
You spotted the capacitor already.
Yeah, I spotted the capacitor, but on which side was it again? I can't see because it's so tiny here, and everything is full of wires. What does the RC filter do? Filter this noise here? So what's this noise here? Oh. Okay, that really looks like a noise. Oh, wait a second. We can filter to 40 kilohertz. Can we?
Activate bandwidth filtering at the scope otherwise.
Yeah, that's good. We can basically filter 40 kilohertz since we know the original wave length. So, okay, let's try. I never tried filtering, but we can do this. This is trigger, measure. How do I filter here? FFT, digital muff. Which one is this? FFT is, I don't want the frequency.
Select the channel first.
Yeah, I select the channel first. Then impedance limit, fine, invert probe. No. Skew probe check. No, that's not. It's not directly at the probe. Impedance coupling DC.
Select BW limit.
Okay, BW limit selected, and then how do I? Okay, it already changed something. I will zoom in. So what does this mean, the BWM? At least we get rid of some high frequency noise already. So this is our response. This is the echo. If we do like AC coupling, that might work better. Does it work better? I don't see a difference. Okay. And now? That's not really great. How is it even able to measure anything? We are at 50 millivolts. So if we do like 10 millivolts, we can see it, but really? Is that all? Oh wow, what's that? That's the scope, or what is this? Oh. Okay, let's DC couple again. No. That's like if it didn't work. This is the signal when it doesn't work. Let me take here this echo. Yeah. Okay. We are able to measure the echo right now. Somewhat. Ten megahertz low pass. It's better already, yeah. So what would the RC filter look like for 40 kilohertz? Can we calculate that? Is this possible? No one can calculate something like that. RC filter 40 kilohertz.
Good night. Good luck.
Oh, thank you, Peter. Good night. Bandpass filter. Oh, you can even buy a component. No. Can we build a bandpass? Schematic of the module. Yeah, but I also want to understand it. Okay, so HC is R04 take, and then let's take a look at the
A band pass to what band? I would prefer Bastille.
Bastille. I have no clue about things like Bastille filters or anything. Okay, this is microscope. Nope. Screen capture, yes.
Music band.
Music band. Oh, okay. T40 and R40. Is there a difference between the receiver and the transmitter? Or are these basically the same things?
That was terrible, I know.
Yeah, you should shame. Okay, 10K, that's what I got. Then we have 10 nanofarad. Oh wow, this is so complicated. Who does something like that? This is terrible. Link again. Oh yeah. Yeah, that's the driver. That's the driver. That's not a receiver though. My opinion is that the driver is really simple. Really simple. Like super.
RX upper left corner.
What? Oh, here, yeah. Fail. Okay. 10 kilo and 10 nano. Yeah, that's basically filtering to AC LM3, that's an op amp that basically 5 volts. Amplifier. This is the bandpass filter. So they are using a bandpass. And they are just using...
Just read bandpass filter.
Yeah. And they are just using a 4 times LM342 op amp.
RC filter.
Yeah. One question though. Is this actively doing anything with the output? Comparator, wait a second. Driver slice. Is this doing anything with the signal? It's probably cleaning it up or anything. I don't know. This is like amplifier, bandpass amplifier. It looks like really complicated. Yeah, that's a quad op amp. I might even have one of these. Let me check my op amps drawer. Op.
Just measure before the comparator.
But you know what? It really doesn't matter. We can work with that, with what we have there. Because we get this
The signal is amplified, filtered and compared to a threshold.
Yeah. The threshold on the first version is fixed. On the second version, we have a potentiometer. Potty. I'm just wondering if I could basically build this as a phase array and we're skipping all the trash on that. The EM78, skipping that, skipping the driver, skipping everything here. Just using pure ESP32.
Sure we can.
Oh, I like that. I like that. up to insulate now. I have, where's my op amp drawer? I have an op amp drawer. That's like regulators.
We're bitluni. Of course we can.
Where are my op amps? I only see audio amplifiers. I know I have a drawer with op amps. H-bridge. We can we can even use the components that we used for the flip dot. We have the high side drivers and low side drivers. Everything is already there. Big. Okay. I don't care. I don't need the op amp right now. I want to make a phase array. Do we need to print anything? It's already so late. I will at least print a plate. Let's make a plate where I can basically plug in the modules. So we have fixed distance. Blender. Let's build one from transistors ourselves, bitluni style now. Yeah, reinventing the wheel every week. Okay, here we go.
I think you need to pay attention to the distance between the modules.
Why? Yeah, I need that. That needs to be fixed, and we need to know that, so we can calculate the precise simulation there. So that's everything here can be precisely calculated afterwards, or simulated at least. We can basically render the interference pattern and try the delays, the individual delays, and we could even, like, if we want to control precise timings on the pins to maybe 40 megahertz precision. Fixed and at a distance for... Wait, is there a specific distance?
Time to chuck some vertexes and faces into a blender and turn it on.
Yeah. Is there a specific distance that would be beneficial for 40 kilohertz? I think you can work, you just need to adjust the time. Yeah, we will adjust the time. This is all right. Okay, I need to measure the... Okay, it's exactly like 16. So we take 16.2. That will be snug. Okay, create cylinder. Radius is 8.2. millimeters. Depth is
Blender 2.79 gang.
12 centimeters, 12 millimeters. Depth. What is that? Huh? Here are we. Okay, this is our transducer. Okay, 16.4. So we have a slight. Okay, and the distance, unfortunately the boards are like, they're supposed to be 20 millimeters wide, but they are truly like 20.2, 20.3. So I will just use 21, even though it's a terrible number. It's not even. Oh, but I want them to as close as possible together. So I will take 22. $22.8 or 20.8. No, we need 20.8. No, that's like really odd. No, I don't want to be confusing. So if someone measures, let's leave it at 21. Really, it should be fine. 21, 20, let's leave it 21. Okay. Well, what is the tolerance on that? Do we even need? Yeah, we need to, for this to be straight. What's the distance here? 10 millimeters apart. Was it 26? Yeah, 26. So it's 21.
Let's make it as straight as one of those bendy rulers.
Yeah, 42 and 26. This is 8 and 68. This is basically, no, that's wrong. No, the complete thing is 41. So let's make it 40. That doesn't, unfortunately 42 wouldn't fit. We need 42 plus 4. Oh, we could. We just clip it at the sides. But I want it sturdy, so I need 44, unfortunately. Okay. This one needs to move like that. 13. Come on. Shift duplicate. Okay, and this is minus. One millimeter? No, 1.2 millimeters. That's 4 layers. Should be plenty. Okay. So this one test print. Oops. Or don't we do test prints? We can do one quick test print and see how that fits. And then print a new one. Okay, models, no, desktop robots, that's not the one. What is the new one? What's the
Test print.
test print? Okay. Phased array, okay. What a stupid name. Phased array. We call it phase array. Phase array. Pardon, did you say phased array or phase array? I said phased array. But the D in English is silent at the end. Phase array. Apple. Pullman's Apple Face ID. Yeah. What? No, export. Export already. STL? Yeah, let's do STL. Phased array, STL. Yeah, export this trash. Cura. Phased array. I need to take a 3D scan of my face, and for the final
Check off list.
yes, I will do that immediately. And I need to take a 3D scan of my face, clip it, and put it over this thing, and then it will be an array of 8 faces. I will check off the list. Check off. Like the one from Star Trek. Okay, visualized, showed on oscilloscope, then simulate in browser, experiment, precise scan. We forgot the 3D modeling.
3D print your face H_L.
Plate, okay. We are not done yet. Ah! Okay, sorry. If you are using headphones. 3D print your face, yes. Okay, exported Cura. Let's drop some stuff. This is not the stuff that I wanted. Every single time. Export STL. And
Let's drop some stuff. Hello, Linus.
what? Is this a meme because he dropped like this super expensive, what was it, monitor, or he broke something? Linus from Linus Tech Tips. Was this the reference?
Linus drops everything.
Oh yeah, that's a meme on his channel, isn't it? Pew! Okay, that's our face array. I will grab. Oh no, the card reader isn't here. Okay, I'll be back in a second. Okay, got the card reader, writer. Okay, slice it.
Asterisk laughs in built-in SD card reader on laptop asterisk.
Yeah. I wouldn't like to use a laptop for this streaming here. I tried, I did it, and it was terrible. 3 minutes. Really? Are they kidding me? 3 minutes test print. I think we can basically print the whole thing. We don't need a 3-minute test print here. Sorry, I didn't get the last thing. This room stinks like cheese. I don't know what the problem is here. It's very cheesy. I will remove that already, so we have some spare space for tools and such, and we can, while this is printing 2 minutes, we can finish the final platey thingy. We just need array, and we need count 8 pieces, 8 pieces like that. And that's all. 8 is what we want, don't we? Fixed and merge. Okay.
Tilde make space for tools. We are looking at one on the face cam tilde.
What? What? %200 feed rate. Look at that. Reload all models. Bam! Ha! Slice it. Done. 18 minutes. Friends, this is gonna be wild. Maybe we take a few more minutes and print it a little bit higher. Let's scale it in. Let's make it 1.6. Oh. Oh wait. No, that. Huh? Oh, not uniform scaling. Ah. 3. That's 1.5 or 1.8. Maybe even 2.1. Let's try that. For stiffness and infill density. 30%. So since we need to code anyways, 31 minutes, that's good enough. You want a flimsy print, but we need like super stiffness goodness here. Maybe even more. But 31 minutes, okay, yeah. Buffering only for you. You could try to reload or turn off like the double speed. What's 24 is a nicer number.
To quote Flex Tape, super strong.
Flex what? Flex schmake? Right? super strong. So let's get me that off. Okay.
Bitluni turned into a chicken there.
Okay. Oh, yeah, no, that's like, yeah, okay. That can work, yeah. But we need to print a tire. I don't know what this...
How to make flexible prints quick.
Yeah, quick is a good word here. So 3 millimeters at least. Okay. Sorry, it will take 40 minutes. Save to disk. No, save to this thing here. I hope this is the right one. Is this the right one? Phase array G code, okay. Eject. Okay, people, we need now some good stuff here. Some work needs to be done. And we need enough wires and cables to even use that.
Coding time.
Code.
Hacker mode. Activate.
Hacker mode activated.
Clipperize your printer.
What should I now do? Clipperize. What is clipperize? I don't know what this means. Oh, fortunately, I have plenty of female pairs, but we might have a problem with the power supply. I need an extra breadboard. Oh no! For the power distribution, I need a. Okay, we can do this. We can work with that. We can manage that. We only need a few male to female that are really rare. Do we even have 16 pins available on this microcontroller? I hope so. Okay, I moved that one here. This is like a small speaker test. We'll move that to a smaller breadboard.
What is the exact microcontroller type?
That's a TTGO. I don't know.
For a first test, you can just plug all TX together and just measure the echoes separately.
Okay, this is done. Sorry, what? all TX together and measure echoes separately. We don't need like every receiver, yeah. So you're right. What we can do is basically use one receiver and the transmitters will be the phased array. So because I don't know if there is a difference, it will be like spread it anyway. So if we were to use like AI, the AI may be able to filter something out there, or determine, we could train it to make a sense of the incoming 8 incoming pulses. But for us, it really doesn't matter if we have 1 or 8 receivers. We just stick with 1 for now. Probably better, it's easier. We are in control of the transmitter, and that will be easy. Okay, so let me clean that up here. Do we need the setup here? Yeah, I rather. Okay. Let me turn that off. Okay, so the precise thing is TT-go, whatever. And it looks like we have enough pins on that. Here, this is the part. It has like a battery connector, SD card, a TF card here, and a switch. Doesn't say anything. The problem is that if we plug it in on to the board, we don't see anything anymore. It's like covering the labels, but we can figure that out, I think. Louis let the dogs out. Okay. Okay, I need to find male to female connectors.
Are the modules roughly 2 centimeters apart?
Roughly, it's a little bit above 2 centimeters apart. It's exactly 21 millimeters. I set it to be 21 millimeters. So what are you? Did you measure the parameters for the phased array? You're doing the homework.
Be prepared to have a beam of sound projected over your face.
Okay.
Sounds very sci-fi.
Okay, I don't have enough wires for that. Oh, where are all my male to female connectors, jumper wires here? I hate it. Okay, I scanned all these here. Oh, that might be it.
bitluni not having enough wires? Impossible.
No.
I counted 16 available I/O pins on a TTGO. Not sure if you can use them all.
This one has enough. We need only 8 output pins for the array, and as an input pin we can use anything above 32 included. No, 32 is still one output, so 33 and above are input pins, and we have 4, 2, 5, 18, 23, 19, 22, 21, 15, 13, 12, 14, 27, 26, 25, plenty. We can work with that. I just need enough jumper wires here, and it seems I have some here. Beam forming, that will be interesting. Okay, looks like I have enough. Peter Griffin. It would be so cool to visualize the array somehow. Maybe in water or something. Can we see the 40 kilohertz in water?
Have we finished the 3D model?
Yeah, it's printing already. We already done. All done. We only need like this plate, and we even made it beefier than designed. It's 3.
Well, checklist P.
Oh, yeah, you're right. Sorry.
Use some paper with some filings on it.
With sound. That works. So Antonio, I must ask you, did you do that before? Because you seem to very like, you seem to know a lot about
Yeah,
this
the
topic.
sound will do stuff.
The sound will do stuff. With some paper with some filings on it. File, okay. Yeah, but what kind of filings you mean?
With GSM antennas.
Oh, okay. Cool. So you worked with like this phased array things before. I know that like Wi-Fi antennas nowadays, the newest generation, they also use like directional antennas that work in the same principle, more or less. I don't know for sure, but that's what I think I read, like the high-speed ones. So
I've seen stuff like a speaker with rice forming patterns.
oh yeah, speaker, but we are working at like this high frequency, so I'm worried that we might not be able to see anything happening.
That's a good point H_L. But you know you can produce some figures with loudspeakers.
I have distilled water, so we could basically submerge one of these transmitters or the whole thing in distilled water. That shouldn't matter really. Especially at 5 volts, it shouldn't. I don't know if it's still working. It might affect the transmitter. Or do you think that's a bad idea?
It should. Trademark. Work H_L.
Yeah, that's what you say.
The speed of sound is different in water.
Yeah, true.
Honestly though, it might not be a good idea.
But it might be a cool idea. I mean, we will never know if we don't try. We could, I have some spare ones. So I got like, how many transducers do I have here?
It's 4 times faster.
4 times faster. So we can use that figure just to see.
Well, have a chance of saying bye-bye to your ping sensors.
Yeah, but we have 7 spare ones. 7 spare sensors. So why not try? We don't need to use every one of them. We can basically use like maybe 3 or just to see if we can control the pattern.
Fair enough then.
Yeah. How many? Yeah, 7 can drown. So 6 would be nice to have the spare one to measure things, but we can drown a few. Okay. I'm ready. This will not work, mark my word.
Think of ultrasonic suspension of particles.
Faye, think of ultrasonic suspension of particles. What do you mean? I don't understand that.
You can submerge them in a sealed envelope 900 man, SSDP, Discover, MX, First, Earn, Dial Multi-Screen Org, Service, Dial, One User Agent, Google Chrome, 96 point. You can levitate particles with ultrasound.
Oh yeah, I saw that. Like styrofoam balls and so on. I saw that. But do we want to try that? Should we build?
What on earth happened LMFAO?
What are you talking about? What's wrong? User agent string. Cool, isn't it? User agent string. Okay, so we need drive.
No, but you can visualize your array with the same particles.
Yeah. True. If we got the frequency right, this will work. Okay, so this will be 5 volts distribution here. And this will be the ground. 5 volts, and this is ground. Okay, bam and bam. You're probably interested in seeing.
Make an array of microphones for the array of ping sensors.
Yeah, that will be like super expensive. But if that works, we can maybe build a custom phased array board like with these transducers. I don't know if you can get them of Mauser. I will probably disassemble one and try to emulate everything that's happening here on with the shift registers. Oh, the shift registers aren't. Emulated with the ESP or any other, like maybe even a basic Arduino Nano, and then
You could also modulate sound on the ultrasound.
yes, yeah, I could if I would control it myself. But if we use an Arduino Nano, we can already get the 5 volts that we need for this power.
Sound inception.
12 milliamps per channel. So what I think, just using, let me show this. Just using a board like this could be sufficient with a nano on top to control the transducers directly.
Then if the array is directing the beam to some direction, you should hear the demodulated audio only in one spot of the room.
Yeah. Yeah, I know what you mean. That would be like really cool. And spooky, probably. Oh, imagine a prank. You hide this thing like maybe behind a sheet of paper or something, and troll somebody with ghostly sound that's hovering through the room. Evil.
We are 24 days late.
Yeah. But if I know me, editing the video and so on,
We should have thought of that before Halloween.
yeah, I have different ideas for Halloween, but you know how long it takes for me to edit anything, so it might be finished by the next Halloween. I thought I have enough wires, but it looks like I might not. Wait a second, what? That's like, I got all the grounds, now I look for all the, okay, I need only like 8 that are more or less reddish.
I think it's time for a new image on the LED wall.
Oh yeah. It's a heart or Australian balls. Okay, it's a bad one. I know. I should be ashamed. Hair on the wall. No, it's Australian balls. Can't you see that? Oh, I'm short of like 2 wires and now I need to take some that are longer than the others. I hate that already. Ah, okay. Let's do it. Okay, this will be the transmitters. I'm preparing the wires here. Okay, so this will be trigger, power, grounds, untested transmitters, we need to test every one of these here. And this is the board. Then we need 1 read. Let's make this one. This one will read. And oh yeah, I have the second board so we can check the pins. So this will be the read pin. Which one do we take? 4, as before. This is our read. Now these are the triggers. I will make a list in the code. It would be the best to have all the pins consecutive, all the 8 pins, but I don't think that's possible in this case. It would be easy with the Arduino Nano. The more I think about it, the more it's like interesting to use like this Arduino Nano without the RTOS as a real-time system and then communicate with the ESP32 or ESP8266 if we need it. Okay, so we have 12.
Four is before. What a poetry.
There's one gap. 24 isn't available in the pin configuration. Otherwise, we would be able to manage that with all consecutive pins. But basically, no, we don't need the desktop robots. Let me do the pins here. So we get this ground 18, we have this is 18, 19, 19, 20 is also unavailable. Okay.
Right now we have Schrodinger's 3D print. Has it failed?
Ah, yeah, you will never find out. Ha ha ha! I'm evil. 1922, 23. Yeah, at this point I will basically leave them like physically in a row, because otherwise I will switch to the other side. That's more sensible, like that. We will use what we get there. Okay, this will be the transmitters. I think all the pins are in one register anyways. We could basically use an OR flag on that and bam, written. Oh, these might be short. I'm not sure. This is good. This is any good. I'm not even, I don't even know if we are able to provide enough current for all the transducers. We might want to add a huge cap there. And with cap, I don't mean Captain America. That was silly. Oh, I need to use another. I need to use 2 on this side. Okay, whatever. Okay. Oh. VCC, ground. VCC, ground. Maybe we should start with fewer. No, we shouldn't. We should always use like the proper amount here. VCC and ground. That seems a little bit wiggly. I don't even know if we are able to put this everything that the all. It's like, how long is this? This will like overlap.
Watch bitluni wire something up wrong and let out the magic smoke.
Yes, let's do this. Let's watch bitluni fail. It's a fail loony. Okay. I'm still thinking if it's rather if we should rather use an odd count here. I'm not sure. Oh, we didn't code the first. Okay, trigger, 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 trigger. This is basically the second trigger. This will be the Bat Blaster or Batman Jammer. I watched a video yesterday. It was like it looked like it was maybe high school or college presentation on phased array, and it was like a demonstration on audio.
Streaming PC leak.
What?
Nice case.
Oh, yeah. It's like I like it silent. It's like be quiet, a cheap one, a cheap be quiet PC. It doesn't have like water cooling or anything. It's like, oh yeah, I showed that yesterday. It doesn't have any water cooling or anything. There goes my address. Okay, but it's like it has a huge fan on the CPU, and it's like from inside it has some padding. So maybe I can show it. There's like some additional foam or anything. It looks okay. I can maybe show you around there if you're interested. I hate RGB.
Basically, it's super quiet. Perfect.
Yeah. Okay. This is the cooling system. I just let me switch to ISO, maybe 1600. Okay. So huge fans. GTX. Unfortunately, you can't buy stuff without RGB today.
Giant heat sink. Perfect.
Yeah, there's nothing much there. There's basically it. It's like the graphics card, the power supply, CPU, 128 gigs of RAM, and 2 SSD cards. And my main storage is on the disk station. Like the backup storage, I'd say. Mostly whenever I'm working on a project currently, I have it mirrored with my what's this cloud thingy of Synology. So I sync that with my hard drive, and whenever I'm done with the project, I unsync it, and it's only then on my disk station, which uses RAID 1. Oh, no, it's not RAID 1. It's like this strange... it has only like one hard drive security, so I'm using 5 hard drives there, and if one fails, I have to replace it, otherwise everything will disappear. Masking tape.
Sounds like RAID 5.
Yeah, something like that. So, okay. That's it. We didn't write the simulation yet. Oh. Oh yeah, this is the receiver. We need to plug it into the fourth. Let's take the fourth thingy here. This is 1, 2. I'm already lost. This is number 4. Okay, let's do 4 here. It's a 4 luni. Okay, something like that. Is this annoying, this list there? Boop. Is it done with the printing? Looks like it might be done, huh? Who jinxed it? Sniff, it was you. This is not what I wanted to print. Even a part of my printer fell off. This is the first time I get a failed print like that. Another 40 minutes lost. Kira, what have you done? Show me the preview. Yeah. Okay. I shouldn't blame you. If I see the preview, it looks inverted. Ah. What is this? I printed buttons. These are like What is this? 40 minutes lost. What is this crap? Ah. Okay, let's try not to merge it and try to export it again. So we can write a simulation while I'm doing.
Some stiff cardboard grin.
Stop.
Should have checked on it when I said about Schrodinger's 3D print.
You jinxed it. It's your fault. No layers to show. What? Okay. 1 hour. Okay, preview. I should never have merged it like. Okay. That looks okay now. 1 hour. Seriously? I trusted you and you failed me.
Minute loss for you is a 40-minute win for us.
Okay. Get it.
Did you say something actually fell of your printer?
Yeah, it's like this this part here. Can I yeah, here. That's just some cover. I don't know. It basically why it was moving this molten stuff around. It ripped it off. Where is it? This here. I can check where this belongs, but did I save it? Yeah. Let me print that. So we have 1 hour left for stuff that we want to do. Okay. No, it's 60 minutes actually. 40 minutes was when I print like this small books. Sorry. I will check now. Flattened rabbit droppings. Stanford bunny droppings. I just trash it now. Done.
And this is why I said about a wireless camera for your 3D printer.
Yeah. Yet another project to my list, please.
An idea for next week: 32 Spanish pesetas cam, ox local.
Uh-oh.
Ultrasonic theremin.
Theremin? What is theremin? Okay, let's write the visualizer for that. This can be saved. Then let me set up everything. That's the wrong folder. Simulator, okay. So, add a file, and we want to add a file sim HTML. And I want to share my screen with you. No. Okay, so HTML, body, script, beep, people, and that's done. No, head.
A theremin makes the music featured in all great 1950s sci-fi movies like The Day the Earth Stood Still.
Oh. Okay. So what body? Body, we want canvas. Canvas width. What do we want? 1000 by 1000.
It makes a sound like wee woo woo wee yee woo woo wevo wow wow.
Okay. Oh, you mean the two antennas where you wave your hands or what? Or is it different thing? Yes? Okay. Canvas. Okay, we grab the canvas, we grab the context, CTX canvas get context to 2D. And from this point, I forgot everything. Okay, let's render East Coast. Let's render the pixels. So we want CTX get, I want the pixels. I want to render the pixels, my friends. Get image data. Zero, zero. Width 1,000 and 1,000. Settings, no specific settings. What are the settings?
Probably missed it. What is the web page going to show?
It will render our simulation. It will render our simulation. We will basically draw our transducers, and then the wave they will generate. If we will take like point sources, even though they will probably not be point sources, but we will take the abstraction of point sources, 40 kilohertz, 21 millimeters apart, speed of sound, and then generate the pattern with what we get if we trigger them all at once, and then we can basically try some beamforming with the different parameters. So we can set the delay basically when they are triggered and form a cone or whatever we want, like a directional beam. I still need to wrap my head around it, how we can calculate this, but it shouldn't be that hard. It's like Pythagoras and whatever.
You need Mephisto 2D.
Mephisto 2D. I just do it like that. That's like super easy. I could even rectangle.
Are you making something to cause an object float on a sound wave?
No, not yet. Oh, we don't need the image data. We could basically, but no, it's better to do that. Okay, it's better to do that. Get image data. I will use it like P. I will use P for pixels, I think. That will be yeah, no, this is data, and then P is data point data. So we can access the pixels. Clamped, that's an unsigned int array. Then we have x as equals 1000. So we can change the resolution easily later. Trust me, we just want to start here. Okay, so this is the data. Then we need to write ctx set image data because we want to I think this is set image data. Set image data. We have 1 hour time to simulate it. Why is this is printing? I'm on the clock. Where is it?
I would check on the print every 15 minutes.
Oh, yeah. Was it sniff? He jinxed it already. Ah, please don't do this again. Come on, where is my... set get image.
Ha ha asterisk evil laughter continues
Put.
asterisk.
It's put image data. Okay. Thank you for nothing. Stupid. Image data and then, okay, so this is the syntax. Okay, so this is basically, and now we need the drawing operation in between. So we will render wave, or let's say render air. That's render air, and we can do pixels as y. That's the size, and that's all. Render air. We will make it gray, and then we will make it hot and cold. Blue and red. Will we? No, we won't. Wait. Let me think about it. Okay. Render air is basically...
Blue will be cold and red will be hot.
Yeah, but what is cold and hot? We have like AC, it's just minus and plus, but...
The closer the hotter.
Yeah. No. Wait. Blue, because we take the color as the current, like... energy level. So we can take do we take white basically? White in the air. PSX and SY, and then this is basically for 4. And then P, whoops, alas. Times SX plus X times 4 . Let's do it like that. I know we should use LED, but I don't know what's the scope of LED is. It's just local scope, or what is LED? I never learned using LED.
Time remaining, 18 hours and 37 minutes.
You troll. It's not a one-day challenge, but I will keep it as a own selected one-day challenge. It's whoops +1. So this resets everything. Air data. Okay, we can test this already. It will basically make it white whenever we press it. Phase array. Yeah, it's already white. That's stupid. And why is my simulate button below? Oh. Yeah, the canvas doesn't close. Yeah. And we need break line here. Okay, yeah. Okay, so we do this with render wave. Then we need
SX or XS, choose one.
oh yeah. This is size, short for size, and S would be step. You're right. At least it was consistent within the local scope. Now I copy pasted it, so I can basically clone that here. And now this is problematic. I would call it like the origin. This is 0. Then we have scale. Oh, let's do it like that. This is the scale, so that's size of a pixel. Then we have the origin, and then we have the phase, pH, which is between 0 and 2 pi. And then we have the frequency. Let's call it F. Is that all? Yeah. And we can simulate render wave.
I heard pi.
You heard what? Phi. So what is our pixel size? Pixel size. Oh, we need the speed of sound, but speed of sound is like a constant. We can make it sound equals 340 per second. Oops. 330 per second. Something like that. I will check this. Speed of sound. 43. That's the speed of sound. That's what Google says. At 20 degrees C, which is basically what we have here. So, okay, so pixel scale. How big is our pixel? So let's make it, let's say 1000 pixels.
Only 24 hours for a one-day challenge. That doesn't seem long enough.
Okay.
Let's get full on geek and make it a 1,000-hour challenge.
1 year challenge. That sounds like if you go to the gym and do something there. Okay, we can make it a square meter. So if we take a meter are 1000 pixels. So 1 pixel is this. This is the scale. Then we have the next origin. That's the pixel, not the meters. 500. Let's put it in the center. But maybe we should use meters here, so it will be easier for us to make our setup. That's the origin. Then we have the phase. The phase starts at 0 for us, for the first one. And then we have the frequency, which is 40 kilohertz. Okay. These are the parameters. So, what we need now is, this is all right. Now we need to know the current location in meters. So x1 equals x times s. The same with y. That can be optimized away. The autos. I hate automatic brackets. I hate it. I don't want it. Ah. It's driving me crazy. Okay, I check on the print right now, but I'm I'm trusting it. Okay, so this will be, this is alpha channel, the last one that you can see because it's behind the chat. Then this is R, G and B. I'll leave it 0. Maybe we should use a like an actual array and then convert it. It would be much more like, why don't we do that? Okay, let's leave it like that. I can change it later. It's already here, everything. Okay, x1. Then we have, maybe I can push that over here. And now we need the distance, which is Pythagoras. It's basically math square root. And then we need that's oh yeah, let's do it this way, like it's even though it doesn't matter. Okay, so we have the distance, and the only thing that we want to know is energy. Or we can calculate all at once if we use an array as phase x0, y0, and so on. And we can do that, so we could render everything at once. I need to read the chat. I can see you. What are you? Okay, energy is math sine phase, which is already do we scale phase somehow? Do we measure phase in seconds? Let's leave it like that. Phase is 0 anyways, but what we need is, we have the distance. Now we divide the distance by the speed of sound. So we basically divide it by that sound. No. Yes. This is right. Divided by sound. And then multiply it multiply it by frequency multiplied by 2 mul math pi. Is this right? Okay, let me check that. No, that should be right. Okay, so let's just take energy. Oh, and the amplitude is, yeah, 1 is okay. Energy times 255, and B is basically energy times minus 255. And this is like 255 minus R plus B, since they are clamped anyways. No, they aren't. Oh! Oops. Okay. That should render something. I have no clue. Probably doesn't render anything and we get a bug here. Okay, let's simulate. Whee! What? What is this? Okay. Eye candy. Oh, wait. We need... No. There is something missing. We need... No, that's terrible. No, that's not good. We need... If B equals 0, B equals G, and then if R equals 0, R equals G. Yeah, that's some color scheme here for you. No, still no good. Okay, I need to do a different calculation here. Let me check that. No G at all. G equals 0 here. Let's see what happens if we do that. And I'm still not sure if the calculations are even right. Yeah, let's leave it like that. But the bluish is a little bit on the dark side. Huh? Yeah. So this is our source of sound at 40 kilohertz, and this is basically a square meter. So what we can well, this is so mesmerizing. My eyes are hurting when I look at that. I should count that. I can't count this. This is like eye cancer. Okay, maybe we should do the scale a little bit smaller then. Let's do a smaller scale. Let's start at 2.5 and look. So
DRAWV, the pattern on the LED wall.
yeah, I did that before. Okay, it's a little bit better. Now we can, so where dark is low energy, and then we have positive and negative, which basically is the same. We could render it a different way, because this is like hot is hot and cold is cold. There is no like, so B should be basically R should be E math ABS. Is there a FABS? No. I hope it doesn't like round to full whatever. ABS and B, whoops. And B is basically minus R. That's all what I need. I don't need all this trash here. Yeah. So this is just an energy state. Yeah, well, you know what? I don't like it either. So I rather revert it. Because I want to know, yeah. I says no. Okay, so let's do this. I cancer, yeah, that's it. No, so we want an array of arrays where this is like, we start, or let's create it. As we have an array of 8 elements. Int, yeah, var. Still at C++ here. Okay, so we need origin. Origin equals empty array. And we push a new element, which will be the origin. And we can basically offset it here. So this will be like X is 21 millimeters. So it's 0. This is a millimeter. So we have 21 millimeters times A. And the origin is, this is plus, the origin is, let's say, 10 centimeters, and this is like 90. Well, let's leave it like 25. Okay, 25 centimeters. This is like Okay, this is the array, and we push it here. I'm going to, this is what it's about. It's about phase arrays. Phase arrays, I-cancel arrays. This will be the phase, which is still like 0, 0, 0. Let's do it like that. P is okay. We need to change this here. This is like origin, and this is an array, and we get x1 these two. Oh no, this is the wrong one. Sorry, this is right.
Your energy is not damping with the distance from the source.
No, but it doesn't matter. Does it? We just want to see the interference pattern, and the frequency doesn't change. So for now, it's just important to see how we get the interference pattern. If I do like an attenuation on that,
Okay.
yeah, it won't change the interference pattern. It will just be dimmer and dimmer the further I go out. And probably we have some, okay, like in close to the array.
What would the simulation show if you had 2 origin points?
Yeah, that's what we are doing right now. We have like 8 origin points. This is the phased array, and now we will calculate the energy for each of them. So we have now equals 0, and now we go for A equals 0 and A, and now we will calculate the energy. We'll just add it, and that's everything we need. And this is all. Are you ready? And I think the printer is done. Oh wait, reload. Broken. Oh yeah, this doesn't work. Oh, this is what we need to change still. Ah, I hate it so much, this crap. It's auto A0. This won't work. 1. You can see that it's basically just putting in the coordinates for the, okay, let's try again. Nope. So what's the problem? Let me check console, reload, simulate. Nothing. What's wrong? What? Where are these spaces coming from? What's wrong here? Oh yeah, oh yeah, oh yeah.
Try printing out your origins.
Wait a second. I think we got a problem with the energy since it's higher than, let me cut it at, or let's do divided by 831 like that. Okay, let's try again. Oops. Because no, doesn't change. Oh, it took a long time though. What's wrong with that? Why doesn't it want it? Something's going on here. Are there like not a number, or what's wrong? Okay, let me debug that. Pixels. Okay, we have floats here. And this one is even, what the heck? How is this higher than? Okay, let me check that. That should be integers, first of all, so we can floor them. But we didn't have the problem before. And why did we get B?
Normalize the energy.
Yeah, that would be times 31. Oh, yeah, here, this is the problem. 31, but that would be normalized in this case. Yeah, let's do that. And we need to floor it.
Can you slide the editor window to the left so the line numbers are on left edge of screen?
Here you go. That might not be the thing I want to do. Let's do that. We can floor R, B equals R minus R, and then we have else I like it like that. Okay.
We need to floor it. How fast we talking?
What? Okay. Why? What's wrong? What's wrong? Oh, that's what the problem is. That's why we didn't need to floor it. We reused
Try the simulation for only a
No.
pixel 0.
that's the phase. I reused the variable name here. That's why it wasn't clamped automatically. So we don't need to do that here. Well, that's okay.
Floor it, like in a car with the accelerator pedal.
That should work now. Oh yes, baby. This is what we generate right now. Oh, this is so cool. Wow, that's beautiful. And NFT. That's an NFT. Dudes, let me center that a little bit. These are, oh, that's so cool. Okay. Yeah, but we don't get like, we get only like cone.
Yeah, that's beautiful.
I don't even need to
Take a
take.
screenshot and send it to us.
I can basically send it as a like on Discord. This is not. Where is the Discord? Here. I will drop it in bitluni's lab here. Here you go. I drop it there. That's the first rendering, but it's not like precisely correct. We still have like only cones that we generating. We have point sources here, and that might not be precise for this area here. That will be precise here, roundabout, but not there or here. Probably not. Did it upload? I can see what. How can I go to? Yeah. Beautiful. Okay, let me move that a little bit.
You have a bottom wall as well.
Yeah, we got everything there. Okay, so
Discord link, please.
we did. What? You don't know the Discord link? Someone drop please the Discord link here. What's I forgot. Link at bitluni.net Discords. Discord. Yeah, that's the one. Yeah. Okay, let me shift the pattern a little bit. That's not the code. We don't need this code right now. Yeah, everyone's dropping the link now. Okay, so that was quick, wasn't it? The simulation. Now we need the 8 parameters to shape a cone. HTTP works as well.
Guess we got 3 note back quote L.
Which browser is this? Okay, I recenter. Huh? That doesn't. Wait a second. Okay, I need to.
Check the print. Stretch your legs a bit.
Yeah, print is done.
I left and came back and now you're drawing some weird squid looking thing. What happened?
That's basically physics. That's nature. Huh? That's not nature. Why? What did we? Is it only like 10 centimeters? Still not centered. So how do we need to center that? Let me calculate. let me calculate the precise position since we're using half a meter. So we want 21 times 7 times 0.5 minus 20. No, that's completely wrong. What am I doing here? We have we have 250 millimeters minus what? Why is this minus? No. 250. No. See, how do I clear it? Okay, 250 millimeters minus 21 millimeters distance times 7, because we have only 7 spaces between the 8, times 0.5, and this is equals 1765. So
bitluni is in LSD, Looney Silly Diode.
yeah, and this is basically, this is centered. Simulate now, baby. Oh yeah. Oh, this is my ether. I need some tools to get this off the plate. It succeeded. So we did this in 1 hour and we can look, sniff, it's stiff. So we got our pattern here. Should I assemble it right now? We can project this in my room here and fry brains. Nice and pretty. Yeah, it is. Okay. We can move it down a little bit. We can move it down by half a meter even. So because we don't project anything. Did we save? Did we load? Did we whatever? We didn't reload. Okay. So this is what we, and this looks like a fabric.
Finally it worked. Schrodinger's 3D print succeeded.
Yeah. Now we need some sliders. I need some sliders, like, where do I need some sliders? Somewhere here to modify the thingies. So let's.
That's Freddy Krueger's t-shirt material.
Yes. So input type slider. Is it slide? I don't know. Min equals what's our desired delays? Microseconds, or what do we do there? Nanoseconds? Whatever seconds? let's start with between 0 and 100, and on change I think it's not fast enough to do it on the fly, is it? On input could be, we can try on input and then update array, we take the value and we change the first one, and this is like this is not the phase. Okay, let's use it, let's make it a global here, phase, and pass it here as phase. Okay, and update array and this value. So we pass this input and we can basically clone that 8 times, and then we have some sliders, I guess. Yeah. Now we need update array. Basically this and V and phase.
Translate on mouse position in real time.
Translate on mouse position? What do you mean? Phase I equals T, and what T means we don't know yet. So basically we have 44 kilohertz. So let's set bar frequency. No, 40
You meant
kilohertz.
to use the mouse position for phase change.
Oh, yeah, but what? No, what? But we have 8 arrays. Which array do you change? Oh, it would be cool to... You evil monster! Imagine you do like a brute force method that calculates the values, the parameters for you, and you just draw it. You upload an image with your drawing. I want this ray, and it will basically calculate what you want. By brute force. Okay, and the phase. So we can, do we just phase shift? We can also use like 6 to 8, and this will be like a full phase. That would 2 pi, I mean. 0 and this will be, because there is no difference in, you can only change it by so much. So phase V times 0, 0, 0, 1, this is basically pi, and we need to add this. This is our phase, and we add this PHA here, and that's done. And we can change the values now with the sliders.
I think you need min and max, not min and min.
Oops, slider doesn't work. Yeah. that was, I just hit this test for you to see if you're still paying attention. And slider doesn't work. Oh, do we have something similar in HTML? I thought HTML5 would support sliders.
Hold Alt key to select multi-lines.
Alt key. What? Ah! What's hold? Wait a second. I read the chat. No need to resend. No. Alt key. Oh, you mean like ah? Oh. Oh.
I put type range.
No. Wait. Ah. Something like click. What? Type range is rape.
Use input type range.
Thank you. Oh.
You should be able to use sliders. W3 schools. Click multiple times.
I don't know how to do this. Huh? Okay. It shows me that that's similar. Now I can no. I don't know how to replace multiple. I don't see. Oh,
Night light 1 and press Ctrl D multiple times.
I try. I really try. Beautiful. Okay, thanks for this new thing that I learned. Oh, yeah, that's terrible. We need the line. Oh. Yeah, okay. But I wanted before that.
Alt D or Ctrl D does the same thing. DADPMKO Fritzbox.
Fritzbox? What do you mean with the Fritzbox? Ah. Oh, okay. Okay. Simulation runs. Now we only need to sim. Okay, it isn't the fastest, but I don't know if we are able to do like, look at this. This is like only five frames already. No, I don't like that. That's like really random. How do I calculate that shit? That's like a quadratic solution.
Now that's cool.
If I upload that on my Arduino, probably
Arrange them like stairs.
half half of the Starlink satellites will crash. Like stairs, like that. Okay, let's try this. No, that's
Send
terrible.
the HTML on Discord so we can make our own stuff.
Yeah, but you need some output here, so you can check the values or copy the values or something. Wait. I will add some fields here where you can copy the values at least. Input. Whoops. ID equals type or text area. No. Yeah, text area. Oops. So I can drop it there. Oh, I could basically use, I don't need to do that. Let's do div. You can copy it like that.
Just create a copy button that copies values to clipboard.
Yeah, do you know how this works with the clipboard? Drop me some code. But I will also want to see that as well. So I will add the button, but you get button copy. What format? C++? Ah! Oh, closing brackets! I hate it! PR and vals. How do we... Is there like a formatter, a basic formatter? I think it was like, oh yeah, we can... Okay, here.
Link in chat for copy to clipboard.
Navigator, clipboard, write text. Okay, thanks. Copy text.
Perhaps you can add the possibility to enable or disable each transmitter.
Oh yeah, that's true. But yeah, I can do that, but yeah, I can that's even more complicated. I don't know.
Put less than PHP echo $value greater than on each slider line.
PHP what? It's not a PHP. Slider line. That's not a PHP things. This is like working on the local machine, like in a browser. It's basic JavaScript and HTML. Okay, document. By ID, and we need vals
If
in
enabled, add its energy to the total amount.
JSON stringify. Haha!
Not gonna lie, PHP can go die in a hole and get buried there.
No, I like PHP. Face. That's what we want. And function copy. But you will get a JSON string because I'm lazy. And navigator, and this is JSON stringify. Basically this. Where is it? Where is it? Ah, I lost it.
Whenever I need to write a backend or API, I just write it in Python with Flask or Qt lol.
Where's my beautiful browser thingy? I lost it already. I don't know where it is. I have like a million different windows open here. How to, this is my sim, okay, yeah. Oh yeah, baby. Yeah, and there you got a problem. What's get context? Oh, there is something missing. I think that's like a tag missing or something. Something stupid. Button.
The problem with a ton of tabs. I have that problem too with over 2,000 tabs.
Button opens, closes, br, diff, opens, closes, canvas still there. What's wrong? Of null. So
Close div.
diff isn't closed. Oh yeah, it's reopening again, and I give up. The stupid auto brackets, and you have to modify this for every single language.
At one time I had over 400 tabs open at once.
Did it copy? Let me check if that copied. Yes, it.
One of the many reasons why I don't like web development.
It doesn't need to be like. But why is it so slow? We are not working optimized here. I could probably optimize this a little bit. But I love this. Yeah, I doubt we can generate like a single array. Maybe if we really switch on and off.
Send it now.
Okay, wait a second. Wait a second. I send it now. I just need, before this spreads through the interwebs, I need to drop my ooh, yeah, baby. No. Or H1.
Use WASM, that'll improve performance or two.
simulator. Sim, and then we need a no YouTube. Closing bracket, fuck you. Sorry. I'm so pissed about this shit. How do I turn this off? I need to turn it off now or I die. Do we need like a license there? Non-commercial license? No, I leave it like that. And basically everyone can recode this. This is like physics. Physics can't be patented. Does it still work though? You need to check this. The simulate, oh yeah, that's terrible font, but oh no, we need to change the font. Sorry. It needs to be beautiful. Body.
License powered by Charmhigh.
Yeah. Style. Style, font, family. Sans. Helvetica, sans serif. Yeah, that's what you want. And this is age, style, text, color, text. Now, what's the color? I die. Okay, let's forget this. Okay, then let's do body on load. You can learn HTML today. On load equals sim, and then we can remove this button. Okay, copy values. And default is value. This is missing since the initial ones that we start with are 0. So and we need some description here. Let's make it div, even though it's terrible, but it has the line break included. So phases. Copy values to clipboard. Okay. Oh, yeah, okay. Let's do vals, make it span, so we don't have the line break here. Span, and take the line break so it doesn't move when we change the slider. Okay. Okay, I'm ready to share it with you, dudes. And then you can have fun. and clip me some. So this goes on Discord. Where is Discord? This is Discord. Have fun. We completely forgot that we have a physical build here. So
The lack of capitalization in this project is playing havoc with my OCD.
yeah, that's your problem. Oh, is this even, does this even fit?
Where are you posting the code?
It's on Discord. This is evil because you have to join Discord for this.
You also forgot about the trailer.
Yeah, I also forgot about the trailer. Oh, please, let's ping me tomorrow about that. I was on the phone the whole day today. I was like, one of the days that I didn't make anything except for this whole project right now. This wire is like really dodgy. I'm afraid this will break super quickly. Okay. I switched the camera.
I will, if I remember.
Yeah, it's the same for me. Okay, I switched cameras.
Or if you don't want to go on Discord wagon, feel free to rewatch the stream and type the code in line by line.
Yeah, that's also possible. So I feel like I might short things here. Ah, that looks dodgy. Okay, this is the third one.
Theoretically, that means more watch time for bitluni.
What? Yeah, doing it like that, yeah, for sure. That for sure, my friends. Oh wait, this was the first one? No, this is the fourth one. No,
Nothing a bit of Captain Tape can't solve.
Captain Tape. Yeah, Captain Tape like the captain, no?
Dodgy is sometimes the best way.
I'm afraid that I lack the precision here to make it as beautiful, the actual outcome, as beautiful as we got it there. And this wire here is broken and I need to somehow maybe...
Straighten the pins perhaps.
Yeah. Oh, yeah, bending. You mean bending? No. Because...
Oh wow, code works.
But it's slow, isn't it? It's not optimized. So probably a few things, maybe changing the resolution. I don't think we need this resolution, so 500.
Yes. Bend them bad boys.
Oh fuck. Okay, this one is dead. The wires are too short. Oh no.
Oi, watch your fucking language, fucking bitluni.
Hey.
Bend the pins, bend the pins, bend
No,
the
it's
pins.
not. It's, oh yeah, but it's not about the pins. The DuPont wires are too short, basically. We can still fit it, but oh no, it's bending already. The whole array is bending because this wire. Okay, I can take a longer wire here. Wait, this is the trigger. I found already a mistake I made here.
Too short. Make it longer.
Yeah, smarted.
Brew.
Brew. What is that? Is this even?
I must admit the tolerances here were slightly overlooked or overly ambitious.
What do you mean? Tolerances? I don't think that a millimeter like makes such a huge difference in our case. Why is this? Wait, what? What is? Why is? Ah, okay, let me check that. Oh no, this is completely wrong. This is the different side. No! This is all wired wrong here. Okay. Yeah. Yeah, no. Yeah, I need to check that. Okay, this needs to go. Okay, so what I can do right now is I can take the longer ones, like that one here, and use them back here. And to prevent shorts, I can basically, you're only seeing my arm.
Should we get one of those IBM Magic Smoke Refill canisters for bitluni or just leave him to his own devices?
Leave me to my own devices, I'm fine. I'm doing great. Okay.
Limitation breeds creativity. Also being broke.
Yeah. I lived that limitation for a long time. Even as a YouTuber, I did that. Like, at some point, when was it? 2019, I had almost to take a day job because I ran out of money. It was like net negative with the years before, and my cash was running out. But then somehow I think I had like a viral thing or something, and the Patreons that made a difference at this point.
How was the fondue this evening, by the way?
Oh, it's
We
gone
need to top
already.
up the fondue fund.
D-
Also, if we wanted to send you some strange cheeses to try in your fondue, would you be up for trying them?
Oh, I don't take like, you
Could
don't,
you daisy chain all of the grounds and VCCs together, so you only have 2 wires for power G'ing to the breadboard?
no. The answer, short answer, no. Nope, that didn't happen. The cheese, so I will only take cheese that's like packed up or something, like not, not like something strange
Or
where I
post
get.
links for you to buy them with the fondue funds.
Yeah, okay. But I need to set this up and I don't know how you can do that if you don't want to use Amazon, because I don't really want to support Amazon unless someone's using one of my affiliate links. So I need 4 and 4, no, 4 is, this is like 2 and I need 4, another 4, which is here. This is the receiver.
Ha 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 ha, down with Amazon.
Yeah. Uh-oh. Okay, I rather take this long wire over here because we need some longer things here.
Ghost chili fondue cheese.
Oh no, I'm not eating hot stuff.
Down with Bezos.
The hottest stuff that I eat is maybe a mee soup. That's all. I take the mee soup powder. I use it if I cook one of the cheap ass mee soups. But that's all. That's the highest of sharp things.
Oh nice, I just got my money. I can do a super chat now.
Oh, Sniff, you got already super chat. Don't do it. Okay. Everything is wired up for the magic smoke.
Kangaroo fondue cheese.
Kangaroo. Okay, so this is our phase array. Now we need, but it's a little bit loose. I need to use some tape maybe on the other side. Hello from the other side. What, Aaron? Oh, you didn't even use a message. Thank you very much. This is like, oh man, that's too much.
Save your money, Sniff, will do it for both of us.
Sniff, did you see that?
Pretty if you only see it from the front.
Yeah, it will look pretty. So Aaron, thank you very much. I don't know what to say. That's like very generous of you. And this like every week, I don't know, it's too much. Okay, this might be not very precise, this whole setup, but it's our test setup. And Sniff, £5 even. Thank you very much. Yes, I saw it, but I still have a fiver from me. Keep up your looniness. Okay, so this is now official. You guys paid for the hour that I spent for this phased array calculator, and now it's public domain. You're free to use it for commercial stuff. Okay. Oh, imagine that. We can use WebGL for that. WebGL and render it in pixel shaders. This will run like instant. Did anyone find any parameters that we can use? Oh, I could change this input back to an input field, so you could also paste something there and it would be parsed. Yes. Okay, cool. Look at this. Look at this beauty. This is my face array.
GLSL via shader toy H backquote L.
Oh yeah, shader toy. Yeah. But we need all the parameters there and so on. Or we could basically drop in the string that we clone here. But then, okay, is there like... Let me check shader toy.
Render it on ping pong wall. It definitely looks like it means business.
Can you add wow, this is so beautiful. Shader toy is so beautiful. I mean, I used that, or that was used to develop code for browser intros. I mean, where's the screen capture? GH5. That looks so cool. Yeah, I accept. Yeah.
Have you tried 3JS?
.3JS, no. What is this? Is this something Brian coded? 3JS? What does it do? Examples? Wait, what? Yeah, that's what I need for my...
Parameter.
We say parameter. Oh yeah, that's cool. That's cool. That's cool.
Parameter.
Parameter. .3JS. What's the license on that? What is this?
Wow, that is cool. Open source.
Yeah, there is a wide variety of open source. Oh wow, that's like object files, geometry. Okay, that's another night that I don't sleep just to check this out. but it looks like an engine, and I'm curious if I can use it for my VR stuff
It's
that
what
I'm...
Fusion 360 uses in Sketchfab, etc., etc. There's also cable.gl.
Okay, okay.
And here we experience bitluni in his natural habitat, the
No.
lab, finding a new cool thing, Deb.
No, that's too much. That's too much. We need to do this. We need to find array. Array. So how do we render a singular array here? Oh, that's cool. So this is the least that I saw so far. We weren't able to do anything different here. Maybe it's really the distance between... You broke. Maybe it's really the distance that we need to change between the transducers. So if we take, let's calculate the distance of a complete phase. Since you can see it's like, what is it, half a centimeter? So we're calculating with 343 meters per second, and the wavelength is let me check that. 343 meters. But I need to write it down. We have calculated that here. So
more secondary school physics, I can't remember.
yeah, I just need to see the where's my Google pen here? Okay, so we have meters per second. So this is what we got. And then we have frequency. This is like waves per second. And then we have so we must divide one. Oh. Yeah, that's cool. How did you find?
Interact with the demo with your mouse. It could produce a 3D representation.
Yeah. Yeah, that's just shader code. Okay, but let's calculate if we can improve our phased array. I want to see if we can actually change. Okay, so like my brain is offline already. It's 2 a.m. in the morning, and now I have to think like this mid-school physics here. So this is the frequency per second, 1 divided by the other meters. So we get this is the frequency. So we get basically waves per meter, but we want meters per wave. This is like SP divided by F ist gleich okay, so we calculate no, this is wrong. CE, we need 40K. I don't know what I'm calculating here, but this is basically divided by 343, and we calculated something. That's waves per meter. So we get like if we flip that, we get 8.57 millimeters per wave. 8.575 millimeters. So if we take the distance between, you can see that, sorry. If we can take the distance and multiple of the wavelength, it might change something. So let me change the simulation, but we won't be able to reprint it. Oh, no, we can't do 60, we can do 24. Okay, where's the calculator again? We can do 8.575 times 3 is 25 millimeters. This is the next multiple of that. We have 21 now, but if we do there's copy, yeah. If we do that, that might change everything. Oh, look at that. That focuses right like here, and this is like quite low. So let's check what happens here. If anything changes here, like a different pattern. We should use a simplex algorithm to find like the least entropy or something. But it's quite wavy here. Okay, I'm back. I think we might need an amplitude on top of that. Like, not like amplitude for or strength for each of those. We can at the same cost of a big pizza.
The mic today sounds much better, by the way.
Oh yeah, now that you ask, because I checked on I spent the money that you donate on stuff to improve things, and this is this Sony Lav, and it's stereo, but it's using the Rode Go, uses only mono, so I'm using only the left channel. I tested it, and I watched a review on YouTube of the lav mics below 100 euros or dollars or what? Sorry. And that sounded like a lot better than the Rode. Rode mics aren't very great. I think the Rode Go 2 is a cool piece of tech, but the microphones themselves are quite noisy and maybe it's not for my voice.
Make my pizza with pineapple and ham. I just got a cheap lav mic. It's not too bad, but it's not the best.
Yeah, that doesn't cost as much. It's, I think, only this microphone. This is like only the microphone, not like no stuff on top. That cost me maybe 30 euros. So it wasn't very like expensive. I was surprised because the quality of that is quite good. Especially for my voice, which has like this deeper parts, and the Rhodes are sound a little bit muffled, or I would need to equalize it, so more like high frequencies, and I don't want to edit anything anywhere. This looks like a cool pattern. Like this is the Hindu god Ganesha. Sorry? What camera? This is my first camera that I started with on YouTube. It's like an old Sony Handycam. You can buy that VH100 or something. You can't buy this anymore. It is able to record, I think, 60 frames per second interlaced or something. Full HD, but interlaced. This is totally Ganesha. I copied that.
I added the amplitudes.
And? Does it work? We are only able to like control on off, but we could basically add amps here.
Look at Discord.
Oh yeah, I will. Oh. Oh. Yeah, but that's two arrays. Yeah, that's only like 2 sensors used. I mean transducers, and you get 4 arrays there. Did you try to adjust the distance between them? I will add the amps here. Just because I'm too lazy to like clone code. Because 6, 7. Update amp. I want to see if what happens at the distance that I'm using now. And this is like not phase, this is amp times zip. I don't use that stringify. Maybe plus that and plus stringifies amps. Okay.
I used a 24-inch speaker as a mic connected to the input of a push-pull transistor amp. I was able to hear someone outdoors whisper from more than 40 feet away.
Okay. That sounds great. And what did they say? Okay, amp, and this is basically times amp A.
I know what you did last summer.
Wait.
Testing 1, 2, 3. Is this mic on?
Aaron, this is really scary. You know why? I watched that movie yesterday. We watched scary movie, and I did what you did. I know what you did last summer. Yesterday in the evening. This is scary. Yeah, that's a coincidence. For a second, I switched to the chat for a second to see if Antonia wrote this, because, like my partner, because she's the only one who knows that we watched that movie yesterday. That's basically this Ganesha waveform that is transferring my thoughts and memories to you right now. We have some kind of resonance wave function here.
Apart from me, I knew, haha. I don't think this is a coincidence. I think someone is stalling you, bitluni.
Oh yeah, it's Truman. Another Truman Show moment. Okay, I think. Oh, and I want to make the distance equals, and this is the step size here, the distance between the arrays here. Distance, and this will be 0.25.
You left your stream running from last week. I could hear the movie playing upstairs.
Yeah, sure. 3 3.5
Now
times.
you're doxing your brainwave.
Yeah, sure. Okay, this is basically that optimized and centered, and this is the distance. This is like, maybe we should make this also a parameter, but this is going crazy here already. Okay. Oh no, this is the default value is wrong. That must be value is 100. Oh.
Your movie tomorrow is either Butterfly Effect or John Wick.
No, I watched Butterfly Effect recently, so I don't want to rewatch that soon. Okay. Did it change? No, it didn't change anything. It's broken. Yeah. Sim. Amps. Probably amp. Huh? Not amps. Where's amps? Where are they? Amps. Amp. Amp there.
If the time permits, we should have a movie night on Discord.
Yeah? What movie would you pick? Oh, this is a strange thing here.
Hostel.
No way.
We should obviously have a vote.
Oh, look at that. That's a nice pattern. It's like this hostel where they used like the finger clippers to cut off the eye.
Max Fury Road.
Yeah, that's a fun one. Oh, I see. That's not precisely. Okay, it cancels itself right here. So this is what I would expect, because the distance between, this is a multiple of the wavelength that we get. So this is an interesting pattern because it's quite subtle, but it has a uniform distribution here. I wonder if professional microphones are like shaping.
Have you seen the Scream to series yet, bitluni?
Scream to series? No. We started with the movies again. So we started
TV series.
Yeah, I know. It's on Netflix right now. We started with Scream 1 on Monday, and yesterday we did I Know What You Did Last Summer and Scary Movie. And now Tony wants to watch the second Scream. So I think we will do just the Scream series until it gets boring. And then we might want to try the TV series, or I don't know, something new maybe. I would say The Descent. And that's a cool horror movie. If you didn't watch it, don't let you spoil it for you. It has a cool ending.
The Purge to series was pretty good.
Yeah, we didn't watch, I think we didn't watch the last one, but the first one, the idea on itself, even though it was like low budget movie, the idea was quite cool.
We should definitely have more fun events on Discord though.
Yeah. I thought it was yesterday, the hangout. I should announce this for the supporters as well, so more people will just join and do like a regular 2 hours or something of hangouts, maybe a week. But I don't want to promise that if I don't feel like sitting on Discord. That was super fun. Okay, what we are doing, what are we doing here? We should reset to our original configuration, which is 21. So I will comment that out and I will do 0.21. And now, anyone got some cool configuration?
Don't watch Jeepers Creepers, it's stupid. Dark on Netflix was good dubbed for us English.
Yeah, Dark, I stopped watching that. I don't know. It was... I think every person looked the same in the Dark. Probably because they were the same people. I'm confused. I watched like the first one and then the second season was so much delayed. I forgot basically everything. And then I stopped watching because I would have to rewatch the first very depressing season of that. I don't get easily scared by movies. Watched too much horror movies as a kid. My brain is already damaged. Okay, I think if we want to scan like target array or something, we can only do a symmetrical stuff. What we can try to do an attenuation of the direction. So basic.
If I want to feel horrified, I just try to code. Enemy is a great movie. Very unsettling. Candyman, Dark Crystal scared me as a kid, haha.
Dark Crystal. Dark Crystal. Enemy, yeah, with Jake Gyllenhaal. Basically, every movie with Jake Gyllenhaal you can watch. They are all cool movies. Like Nightcrawler. Was it Nightcrawler? That's a cool movie with him. Very creepy. And also...
Nightcrawler was awesome.
Yeah. I think that's one of his best.
Zodiac.
Yeah, Zodiac. Sure.
Wizard of Oz 2 is super scary.
Really? I didn't watch that. Yeah, the spider, it's too long ago that I watched it, but it was like some kind of metaphors for something. I read some interpretations of that. I think I watched Chris Stuckman, that's a reviewer on YouTube. Or he did movie reviews now.
Prisoners with Jake and that Australia guy was awesome too.
Yeah. Yeah, Prisoners is great.
I watched Ghostbusters Afterlife on Friday and it's really good. WAYYYY, better than the 2016 one.
Okay. Ghostbusters Afterlife? That sounds like Resident Evil After. It's in cinemas right now, yeah. We have like COVID deluxe here in Germany.
The
No,
remake of Wizard of Oz was interesting. I really like the first Resident Evil movie, not the many sequels.
Yeah.
Nothing beat Babe Goes to New York.
Babe Goes to New York. Or the Smurfs. The Smurfs. Paddington Bear. That's a cool one. It's so hilarious. Uh, okay, so how do we calculate anything here? There's not much we can control with our array here. Okay, we get 4 arrays.
Babe was nice.
We should arrange them in a way, in a manner like distance of like prime numbers. So we can basically create any constellation.
I must admit my favorite in recent times has to be The Departed.
A recent time, that movie is like really old. Or did you just rewatch it and it got better like the second time? I watched it a few times already and
The Departed.
The Departed.
Should run a script what just makes every single combination of values.
Yeah, but I think we need to use a shader for that, or
Okay, recent may be a stretch, lol.
stretch. Yeah, okay. So we can but turning these on and off, I don't know if that does much. Let's try some patterns on. Oh yeah, we need to turn on everyone, every single value here.
The output seems more uniform now for some reason.
I changed it back.
Children of Men is one of my favorites.
Oh, are we talking sci-fi movies?
I also recently watched R.I.P.D. with Ryan Reynolds in it, and it was pretty good.
Oh, I didn't watch that yet, but I like him in what's the superhero movie of his, Deadpool. That's a hilarious one. Deadpool. Best sci-fi movies. Come on, guys, drop it.
Deadpool is absolutely great. I saw Alfred Hitchcock's The Birds in the theatre. 3p.
But not on release, on first release. Okay, we get this. Oh, yeah, I wanted to change something. So this is what we get.
I can imagine bitluni at 80 years old review Halloween 52 and spoiler Mike myself still ain't dead.
Review Halloween 52. Okay, so if we want to like take a scan of the area using the phased array, let's assume we can do something like this here, I think we won't get anything like here because we have a cone shape. I should implement this attenuation regarding like the angle here. So we have the actual cone, but if we just use 7 arrays, we can get these like 3 rays, and then in the next pass we can basically just shift the rays somehow a little bit. Can we shift them? Just rotate them a little bit. Wrong direction. And take basically a scan and maybe that's a clean that's some clean rays here. So if we take like a sweep with 3 rays, we can maybe solve the results to like render the whole, to get actual distances of every point here. Oh, this is like, this is great. I like that one.
Event Horizon is one of my favorite sci-fi horror movies.
I like Sunshine. Even though the end of this movie isn't that great, but the mood and the topic and everything around that is really great. Sunshine is a good sci-fi movie. It isn't very well known, but a must see.
What are you trying to accomplish with this project?
I don't know. It's an experiment. Basically, we build it, and now we simulate what we could scan or how we could use it to get basically. So imagine you have only one of these here, and then this is like, I don't know, it's is there any spec sheet on the transducer what the cone size is? So you get just a distance of this cone of like 20 degrees probably, and this is all. And using multiple of those in an array like that, you could target
Ultrasound imaging. Progress at the moment would be a positive. I think we're distracting Looney.
Yeah. No, but it's fun to play around with the values right now. I think it needs some kind of dull coding now. So I would basically improve the calculation speed on that and try to automatically determine parameters where I maximize, let's say, a point when I click here, I could try to implement a simplex algorithm that seeks for like the maximum parameter set to scan like this point. It will probably then scan also, like we can see right now, this is like, this looks like really great saturated here. So this is probably like a local maximum that we can achieve for this point, but we also get these points here. So we will scan 3.3 rays at once, but if we can...
How long do you think that'll take to calculate?
Simplex? It's quite stupid, I think. I don't know. You could do a brute force. I mean, you can just scan a coarse set of parameters, and then I think there are no like jumps in this. If you change the parameter slightly, the result only changes slightly, so there is no surprise there. So I think this can be easily like optimized or scanned for maximized solution here. If we could, like, the separation of these rays, if we could rotate this, keep the distance or like the angle between the rays here, if we could keep the distance equal and then take a sweep and then change the angle between the...
You're trying to make a device that makes focused energy waves at a remote distance.
Yeah, in this case it would be just, yeah, focusing the ultrasound, and then it's equivalent to scanning like a specific region, like to get a result. So we can make a radar display with this, like an ultrasonic scanner for like maybe the belly or anything, but in the air and the distance, and maybe see like on the display. So I don't want to give projects away, but I want to rebuild this scanner from Aliens, the second one. I love this scanner, and I want to use one of the small CRTs that I got to rebuild a similar device that is basically functioning. So, where is it? Yeah, I got it somewhere here. Where is this device? Yeah, it's a similar CRT. It's a similar CRT to my Game Boy.
Ultrasonic remote imaging. Air sonar bitluni trademark.
Yeah. Not bitluni trademark, it's like Aliens, technology from Aliens. So it's not invented yet, but it has to use CRTs. The only thing that I'm sad about is that they have used what it looks like for the scanner. I can maybe show it. Someone rebuilt one with a TFT display, but I want to use a CRT for that.
That looked like a Game Boy prototype.
No, that's a project. You can find that on my main channel. This thing here. Let me show that. So that looked like a CRT, but it could be some kind of back projection. But I think that's a CRT, and it's probably deeper than you want to have, because I think it's even color CRT.
You have a main channel, haha.
Yeah, I have a main channel. And no, not that scanner. Yeah, here. So this is like, I agree. So it is a color display of some sort, but color CRTs are like really deep. So I can't use that for a ultralight scanner. So I will make it in black and white.
I saw a really cool video about round LCD displays from 2 inches to 23 inches in diameter, I think.
Okay.
Can you not put a lens in front of a TFT to give you the effect?
Yeah, you can, but I want a genuine one. I want a real CRT. It has to look like not like exactly like that one, but like one that could be used in one of the movies. I'm a really real fan of especially the second Aliens movie. So it's like, the design, everything in this movie is so great.
But loony aliens aren't real, haha.
No, they aren't. Unfortunately. Okay, so do we want to try this? Let me check if I think this gets, does it get less focused or more focused if we oh, this is deactivated. Okay, this is the one. I'm curious if we can basically take...
I vote get the hardware hooked up as a baby step.
Yeah, the hardware is done. We need to code it and then submerge it in water and see if we get this result. It's 5 volts. How should it... I don't think it should break or anything. Oh, this is the receiver, so transmitters. We could see the pattern like that. Yeah, 12 black and white TV tube. Yeah, I have some TV tubes here. That one here isn't very deep, so, but this is black and white. The color one, I have a color one that is like this deep. Yeah. And
They make waterproof ultrasonic devices.
easier. But I don't think this will break if I submerge it in like water. Let's try this pattern here. Wait a second. Wait, this is like a full face. This doesn't... We don't need to change here anything. Okay, so face. Let's find a simple...
OWW my ears.
Sorry, what? Uh-oh. Did I do something wrong? I try to concentrate the rays like that. Here you go. It's like lasers. Okay, this. Laser sharp. Okay, so.
You tazed the mic. Light amplification by stimulated emission of radiation.
Oh, I tasered the mic. Uh-oh. This looks great. Let's take this pattern. Now, I need to code that. Right, 10 microseconds. Okay, so how long is a phase? A phase is, we get 40 kilohertz, so So we get 8 delays. These are like phases, or that's even double. These are the phases that we calculated. It looks like it should be symmetrical, but I just leave it like that. We copied the values like that, and then that's not unsigned double, it's double. Unsigned, unsigned long, micros, nanos.
In the movie prop, they use a 4-inch Casio CTV 8500. Good luck finding one of them.
Unobtainium. Unobtainium. I looked for these. Look at this. That's Mike's electronics stuff video. I watched that yesterday night. Helped me to fall asleep. That's like super expensive. Oh no, that's not the one. This is only the remote. Let me. Whoops, builder. No, we can't. Oh, this one here. Yeah, that's not available anywhere. Oh, that's LCD. It's basically unobtainium. Oh, here. This is like 6-inch, 159, and it's probably broken. Okay, whatever. But okay, that one could be probably used. It's a 6-inch, but 6-inch is already quite big. What was the Casio? Oh, 4-inch, yeah. So that's unobtainium. I don't know if you can get one of these. Probably.
And 400 VAC, haha.
Yeah. Yeah, but it's like only a transformer. So what's the delays? We need to calculate. I should. No. DTs. Okay, let's call it DT. Okay, we can calculate these, but we need to get an impression what a phase is. So let's calc that. So we have that's easy. 1 divided by 40K. And that's basically 25 microseconds. So a complete phase is 25 microseconds. That's so hard to time if you have like extra code there. 25 microseconds. We should take cycles there. We should count in cycles. Let's make it.
Does anyone know if they make a I2C 6-digit counter that can counter 1 MHz input?
What? I2C 6-digit counter that can count 1 megahertz input. I don't know. Aaron seems to know. No, Aaron's buying the CC.
Apparently that device uses the Casio CTV 8500 Luni.
Oh, 23 pounds. Are you sure that that's a color display? Doesn't look, oh, yeah, the screen has a crack. Good luck with that. Or is this in the plastic? No. That looks like glass, isn't that? That crack. TV screen got small crack. Where is this crack? Is this, no, it doesn't look like there is like a protective. That's a crack in the glass of the tube. Or is the protective like layer on top? Doesn't look like that. I think this thing is about to die. It also doesn't look like it's color display. Maybe it's okay. Loony. Okay, so let's calculate. Let's calculate, my friends, what a second is. So how many cycles we get per second. So unsigned long.
I'll keep hunting.
Okay. I know I saw some collectors selling this for hundreds of euros. One of the really small color displays. They are really rare. C0 equals ESP cycle count. Then more or less. We will know for sure what this ends up being, and we remove that. Or we can basically remove all that stuff here right now. I just want to see. Okay. Just in case we get magic smoke here. Nope. Did we check off the pink LED? Yeah, we checked off the pink LED. Okay, so this seems to be working. Oh yeah, Cura. Serial. Okay, it looks like it's time to go to bed. 3 o'clock already. Okay, we need that. So it's 240, 240, sorry, you can see anything, screen capture. 240 megahertz? This is the clock count? Yeah. Okay, that's no, it's a voxel. Luxel is right. A voxel, okay, yeah, voxel, luxel is right. No, it's lux, isn't it? What would it be for sound? Oxel. Oxel, that's cool. Okay, let's see, we want on and off. On time and off time. Because we can calculate those. This is full phase, and we can do no, we don't need even like unsigned long is good enough. 240 unsigned long. Oh, good night, Simple. And now we
Oops, I typed the wrong thing, lol, I'm so tired. Going to bed.
join Simple Electronic. Yeah. Blah, blah, blah. Unsigned long. And then we calculate what is this, a phase? Clocks per phase equals x tal divided by frequency. Frequency equals 40k. Just like that. So a full phase is this divided by this, and then we just need to multiply these values. Full phase, this isn't needed anymore. We don't use like baby units here. We use clock cycles for most precision. Okay, we don't need that stuff here anymore. I think it's not long, so we will be able to use it. It's like easier than the other code. I would bet like 20 minutes we're done with that. And now we need to turn it on. So basically on time. Oh, we need like unsigned long micros 10 microseconds. So it's basically xtal divided by millis, and this is 10 microseconds. This is what we waited here, 10 microseconds. Okay, so this is micros on time. Dot, dot, dot. Unsigned. What we still need is the maximum time that we have to wait until every ray fired. So this is basically max start time equals 10 micros plus a full phase. Best you can find in 10 minutes. Yeah, but that's huge, isn't it? How big is that? We need 3-inch. Is this, how big is that? JVC. Let me check that. 5-inch. So this is almost twice as huge as the one from the movie. That's like really...
The movie uses 4-inch.
4-inch, okay. So let me check. This would be 4-inch. This would be a 4-inch display. And this is 5-inch and this is 6-inch. So this is already huge, and the depth is proportional to that. So if you have, let's say, twice the depth of the span of the screen, we have like 3 inches. It will be like 6 inches deep, like that. But if you have like a 5-inch screen, it will be 10 inches, which is already... That's the problem with all the color screens, because you need like this depth for the color, you need this high voltage and this depth. But that looks already, that looks really nice, I must admit. Yeah, it's ultra deep. It has even like video inputs. You could totally attach an ESP32 to that.
You can see bigger aliens with bigger screens.
Yeah. Okay. Okay, let me finish that. Max start time, micros plus a phase. Clocks per phase is that. Plus what do we wait for? Something extra? No, I think this is all maximum. This should be... Let's do a threshold, but it's not possible. If we have like 4, 6. This will be a full phase. 2 pi. Then we have the, no, this is the max time. Okay, so on time I equals phase I divided by 2 times math pi times clocks per phase, and we need to make a long of that. That's the on time, and off time is 10 microseconds later, which is basically on time plus. That's like preparation.
I have a 1.3-inch B in WCRT. Sony Watchman.
Oh yeah, okay. Oh, what? $700 motion tracker. Is this working or it's just a prop? I want a working one. Now in stock. This is crazy because people pay such money. Wow, this is cool. It looks great though. The CRT is this is like a fake CRT, or is it even? The original sound is a little bit different. This pulse.
People can't see your screen.
Yeah, I know. Okay, I show it. You just need to click the link. Yeah, it's not perfect, but it's. So what I want to do is implement one that actually scans and shows on the display the distance to objects. So I might not do it with a phased array, but just with an arrangement of these transducers like in half a circle. Crazy thing. Nice prop. But I want a working one, and I will build one. It won't look like the same as in the movie, but you will get the impression it is the same. You just want me to fail my 20 minutes goal, or what I said. Next break is when this is working. Oh, we need the pin configurations. So pins are now I need to check for the pins, for the actual pins here, which are, okay, the first one is 2. We got that one before. That's 2. And then we have the consecutive ones here, which are basically 15, 13, 12, 14, 27, 26, 25. Okay, these are my 8 pins. Now I need to set these to output for I should call it pin, since the other the tasks are also, okay. This is like that. Then we have the pins. This is the input still. Now we got delay microseconds. So what we do now is we get the cycle count.
Next version could use those little microwave Doppler motion detectors tongue out.
Microwave Doppler motion detectors. Okay, I don't know. Maybe you could link something? Brooks is, oh, yeah. Yeah, you can drop a link. Okay, we start at this. Then while is p cycle count yeah, it doesn't need, what is that? Unsigned. We also need to bool start at 8. Oh no, we need to do the started here. That's every loop. Cycle count, while cycle count is smaller than t plus max start time. That's basically it. So we will run this loop only until we reached like the maximum that is possible, because we can only like shift a complete phase plus 10 microseconds. So whenever now we need to go for all 8 arrays, which we calculated the start time in clock cycles and the end time. What did I do again? Sorry. Maybe there's something. Is there something bad here? If not started, I and oh, we need to cache that. I don't want to fetch it all the time, so let's do a while, whatever. Okay, while, and this is CT. So let's let it finished, and equals ESP counts current time started, and current time is bigger equal let's leave it like that. No, it should be already past that. Bigger equal than start time, on time E. Wait, what? Where is it? On time I, else if we need digital write high when we passed the time where it should be on. So pin I, for each pin this is happening, and no, and if maybe we should ask here to optimize that if not started. So this only happens if not started, and this happens like that, and then else this only happens if it started already, and then if CT is off time, oof time, then we set it low. So this will turn it on and then off after 10 microseconds, and this is basically what happens here. While timeout digital write low. This was our phased array. Timed output on array. Okay. And this is basically waiting for response. Response. Okay. And then we calculate dt by, what is CPM? Did we set this somewhere? CPM. Clocks per meter. We calculated that already. Okay, interesting. Okay. So that's basically it. I think that should work with our phased array. And I try to find some distilled water. And, oh, the scope is still running. Yeah, that doesn't work like that. Long phase, here's a bracket missing. Uh-oh. Yeah. It's out of scope already. Okay, let's do it. Oh, yeah, that's the RCWL Doppler modules. Let me check that. Oh, this is crazy. So is this like an onboard antenna or what? Interesting. Why isn't the fail not working? Probably because... Oh,
Be careful, or some
okay.
people may think you're an actual coder.
Why? Okay, so what is it measuring? Is it measuring anything? Does it work even? No. What? It doesn't do anything. It's broken. It's stalling. Does it measure anything? Do we get anything? Nope. T plus start time, T cycle count, CT cycle count, T plus motion through walls. What? Did I swallow the microphone? What's happening? Is this overdriven? Or?
We just swallowed the microphone.
What's happening? Do we have like wah, 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 wah. What facilities are you talking about, Adam? Oh yeah, that's probably because I'm using my jacket here. It's a little bit cold. Ah, is it stuck? What's happening here? No. Okay, it's uploading. I just want to... What is that? It seems to stall after the first calculation. $1.50 m, and this is 27. Okay, it measures the distance, but it gets stuck on the second loop. So CT Okay, let me output every measurement. Maybe it's only breaking on the second run, but this isn't. Or sensing needs to be. I don't think you can do imaging with PIR. No, it's measuring 0 after that. After the first measurement, it's broken. Okay, so let's check the code. DT There's no way this can be 0. Or it's basically, yeah, it's basically the digital pin is set to why not digital read, and it's high. No, it waits for it to be turned off again.
Stay warm, we can put up with it.
It's okay. I'm warm right now. I'm wondering if it's already triggered by the first one. No, that can't be. It's only like a few cycles. Something's changing on the state. That was TTS from 5 minutes ago. I can restart it because I don't know, maybe the stream duration already makes it vulnerable to, prone to errors. Just as the other thing also is, maybe it needs a reset, this one here. Haha. Ah, that one got stuck. Yay!
Only 15 hours and 37 minutes to go.
You know what? I think there is something, there is missing maybe digital write low. Oh yeah, it is. Oh yeah, it is. Here. We don't set it on. Started. Okay, so I didn't count the debugging into my 20 minutes apparently. So it's never turned off. Now it should work. Peeps. Okay, so this is the phased array. I'm wondering, okay, so what we are looking at, I try to move my hand so it's invisible. So we get, now we get the reading. Here it's not detected. Okay, you can see that. Let me switch the camera. How do we do that? I need to move it somewhere here, and yeah, that's better. Basically,
Like I said, not started.
oh, you said that. Okay. Thanks. That was hours ago. I needed you. You failed me. No. Oh, good. Okay. So basically, it's measuring the distance to my ceiling right now. That's 1.5 meters. Now, it should, like, if I move it in front of that, we have 20 centimeters. That's like, oh, you can see. Wait. Okay, so we get 20 centimeters. But can we sense that here? Okay, we can sense it here. But here it gets invisible. Here it's detected. Maybe we could track the position that's detected and that's not detected. And we should probably see something like that we calculated. Now, I can...
OMG, you are still here, and that a little Linu? LOL.
You again. Dude, we have a working phased array and we calculated. So we have a beautiful simulator for that. So this is the beam that we are forming right now. Probably these three rays, because these are like too steep. But these three rays are our focus zones. And this is the output, the distance output. If it's high, we are not detecting. And if it's low, we're detecting. So we can...
Hey everyone. Again, no notifications from YouTube, boo hiss.
Yeah, I'm sorry. It's on Wednesday, the same time every week. Adam. Oh, and it's not Adam, it's Unexpected Maker who failed at it again. Same time, say every week. Yeah. The text-to-speech is delayed. The stream is old.
Steals one of my cookie and hands it to bitluni.
Okay.
Congrats.
Okay, so we have like a window where here, so if you can see it, I'm using just in front of this array, I'm moving the pen, and we have basically like narrow windows where it's detected. Here was a, let me check it. Here's the window where it's detected. Here it isn't. Here it's detected, isn't. Okay, can't find anything here. So this seems to be an area where it's detected. Okay, now we want to visualize it. Since we are done, basically, okay, we can't create a nice scan because we need to basically calculate the parameters for the beam forming like that. So we need an optimal sweep of the beams, but we can visualize it. I want to prove. Let me get some distilled water. I might need to go to the garage. I don't know where this water is, or I take just basic water. Tap water. Okay, guys, I need to go to the garage for the distilled water. What are you talking about? So, how do I do this? We need a container. I don't have much distilled water though. I don't want to use isopropanol. I could use isopropanol. I have more propyl alcohol than, but it will be a huge mess if I use IPA for that. I rather use distilled water. I don't think we get like shorts or anything. If the stream ends off all of the sudden, if the stream ends all of the sudden, you know what happened. Waimuni is away. Whoop. So peoples, this is like 100 years old. I found it in this house when we moved in. Is it even enough to cover the surface here? Yeah, it is. Okay. Fail SMS smoke detector. Yeah. Okay, so I hope we can see something. And I hope the sensors don't break, so I would need to spend another few bucks on that, but we got some cool donations today. So let's see how it works. These are the these are the receivers. So this must be the transmitter, yeah.
SMS smoke detector.
Okay, oh, uh-oh. One transducer detached from power here. I get shocked right now. We can't see anything here. No. That doesn't work with water. I don't see anything. Okay, let's try the different side. I don't think, oh, it entered it. I still hear it clicking. Let's try the other side, not that the label is wrong. Wrong. No. No. Doesn't show. Okay, so that didn't work. Is it still detecting anything? Oh no. It's detecting 12 meters sometimes. Or short. No, now it seems to work somehow. But it doesn't show. I wanted to... yeah, I need to dry it now. Let me get some tissues. Trying to make fog? No, I want to see the waveform. So how can we display it? Oh, shoot. This is the receiver. Oh yeah, the receiver detached from, where is it? The receiver needs to go. No, this is a transmitter. No, this is ground. What is this here? Where is this coming from?
Use hair dryer to dry it out.
I think the surface tension will just pull it out. It should work already. Yeah. No? Somewhat. Yeah, I can use hair dryer. Or we will continue with that stuff next time. But I can tell you, I'm already happy with the result. We can concentrate, like spend, next time we do this project, we have 1-day challenge next time, but next time we continue with the ultrasonic phased array. Yeah. Yeah, there is something terribly wrong already. No, this is like 3. I don't want to connect it anywhere. Where is it? This wire is always slipping out. I think I will make a board for that. Okay, that doesn't work anymore. No.
Sensors sponsored by Charm High.
Yeah. Okay, I will dry this one. It won't corrode, it will work, most probably again next time. And I will maybe design a board around this. Just to not have this wiring here. You know? Like... I can hear it. We can maybe make a setup where we can measure it controlled, like use a receiving sensor to sweep it. and see where we get a response. Fog and a laser level. I don't have a laser level, unfortunately. I have fog, though. 40 kilohertz. What can you do with 40 kilohertz? That's not like even strong like even a strong ultrasonic or a good frequency. Okay, this is like random. That's not working at all here. Nope. 12 meters. Oh, this one detached. I hate breadboard wires here. Out of those options, it was the laser level that you didn't have. But we have pink LEDs. Okay, people, we need to wait for this to dry. I think that will be next time. And I have like, let me move that over. This is what we achieved this time. A cool sensor array with pink LEDs. Like, look at that. Like phased array. Let me check the boxes here. So we did the 3D model, print play. Oh, we didn't check stuff forever. We simulated, we did experiments, but we didn't do a precise scan, and we didn't have time for So but this is our cool simulator that we can calculate our beamform. So there is still something to do. Maybe I will continue on that off screen.
The transducers on a vertical mounting bracket, the attacher test target on a liner actuator to sweep target across test area.
Yeah, I did that already. Check my scanner video on the main channel. Oh, you mean a linear actuator to sweep the target across? No, but I did like a small scanner, 3D scanner, that sweeps like a hemisphere. But it wasn't great. It's terrible. The transducers basically have a too wide angle. That's why we are doing this phased array. This is what we want to achieve, like to form a beam here. It's a really cool tool. I will drop the latest version of the tool on the Discord again. And you can play around with that. I think it's time, isn't it? Dudes. I'm so tired already. I was tired when we were starting the stream. Yeah, you will get results. I will do a video on that. I think that's a great opportunity to design a board to basically plug this in, and I can get cash from Isla for that. Yeah, phased array. You. The renderer is slow, but
Need extra fondue.
need
With the T-Street I mentioned, you can map sweet spots.
oh, with what? With what? That was the quickest stream ever. Yeah, we are streaming already for hours and hours and hours. What did I miss? TSTL mentioned sweet spots. Oh, you mean you want one? Okay, yeah, that's what I think. Automated, like rotational tool, rotational or translational tool, maybe on my pick and place, because that's a huge gantry, and we can precisely measure the input. We can precisely measure the input that we get from a receiver there. So we could scan that and see if our phased array is doing what it should do. Or we set up basically stuff on the table and try to scan the table, like the obstacles on the table. Something like that. It will be an interesting thing to start with something that's already working, and yeah, optimize it from there. Okay, everyone, I'm totally done for today. Amplitude mapper or something. Yes, that would be cool. That's basically one sweep. We need only to correlate like the current position with the actual. All I want to see is getting aliens from the scan. Yes, that's what we want. Okay, everyone, thanks for watching, for joining, and thank you very much for the grateful donations we got from Aaron, we got from Johnny, and from Sniff. Test the dead spots. Oh yeah. But I don't think we can do it as precisely as that. Bye bye, everyone. Sniff.